The world of software engineering is changing faster than ever before. Artificial intelligence is transforming how we build, test, and deliver exceptional user experiences. To meet these new challenges, quality engineering is also evolving. Welcome to our next chapter. What started as a local community initiative sponsored by EPAM has grown into a truly global movement. Today, QAHub connects professionals across Central Asia, Europe, India, Asia, North America, and South America. More than 15,000 members worldwide, thousands of engineers, hundreds of speakers, one shared mission to shape the future of quality engineering and testing together. None of this would be possible without our volunteers, community drivers, core team members, and stakeholders who continue investing their time, knowledge, and passion into growing this community. And it couldn't continue without you and the investment of your time, curiosity, and collaboration. This year, one question stands above all others. As AI becomes part of every stage of software development, how do we build trust? Trust in tools, trust in methods, trust in outcomes, trust in the brands behind those experiences. Over the next 2 days, we will explore how AI is transforming quality engineering, testing organizations, automation, development practices, and the role of engineers themselves. Join QAHub's global thought leaders and practitioners as they share real-world experiences, lessons learned, and a vision for the future. Srinivas Labani and Bianca Martinez, carving the future, quality engineers reinventing themselves in every tech wave, and generative AI is no different. Mitrai Gumeniuk EPAM AI tools in action. Our way to testing and spec-driven development, Nailesh Singla AI augmented open source. How the Kubeflow Pipelines team uses AI agents for development and testing at scale. Marco Arevalos Human AI Synergy. Practical models for hybrid testing. Excellence, Elena Ulyanova and Kamil Bogdanovsky test. Smarter, not harder, QA custom AI-based framework on Salesforce projects. Tariq King towards trustworthy self-testing. Generative AI agents. Melissa Benua. When the signal lies, designing QA systems that earn trust. Jan Schwenzian and Francesca Morando Agentic. QA, how AI agents become colleagues. Carlos Andres Munoz. Sandoval building a tester community through various social media channels. Natalia Moiseyenko and Daria Poluektova AI in quality engineering. From theory to enterprise transformation. Daria Alyakseyeva. What actually happens when agentic QA meets enterprise reality? The future of quality engineering is not being written somewhere else. It is being shaped right now by us. We are engineers, testing leaders, quality innovators, and QA team members. It's an exciting time to be a quality professional. Welcome to the QAHub Summer Virtual Summit 2026. Let's build the future together.
Good morning, testers and fans of quality code. The second day of the summit is kicking off, which means it's time to catch new insights, share memes, and get inspired by best practices. Are you ready for discovery?
So, I'm glad to see everyone here as we kick off the second day of our global and unique summit. Stay with us. It's going to be super cool, informative, and a lot of fun. Plus, we're pumped to launch an awesome competition for everyone. Score cool prizes by completing the challenge. Tag us on any social media platform and win a prize. More tags, more chances. Good luck, everyone. Now the day opens with another world-class speaker. Please welcome a managing partner in technology consulting and a senior project management expert. His experience includes implementing technological solutions that fully meet business goals, as well as a deep understanding of all stages of software development and best engineering practices. He successfully builds corporate system architectures, implements high-quality standards, and inspires teams to achieve outstanding results. Thanks to his leadership and strategic thinking, even the most complex projects are implemented efficiently and with maximum benefit for the business. Tariq King, over to you.
All right. Well, I hope everyone is enjoying the summit so far, day one. Let's kick it off with day two. let me just share my screen here. 1 second. And we'll get started. All right. Now let me just launch the PowerPoint. All right. All right. So today is going to be an interesting discussion. I wanted to make sure that we keep the QA and QA Hub. I wanted to talk about a subject that's pretty close to me. And so we're going to kick it off today with talking about the future and how we move towards trustworthy, self-testing, generative AI agents, right? Especially with things moving so fast. And so in terms of the agenda, just run through, I am going to talk about a little bit about the evolution of agentic AI and how we've moved from agents from rules into reasoning, and then get into some of the superpowers that I think generative AI actually brings us, and then what we have added on there as a part of taking large language models and then also extending their capabilities with true agentic capabilities, and why that actually erodes trust. Because we're living in a different time where we're seeing a lot more dynamic behavior at runtime, and that doesn't lean itself towards trust. But the good news is that we can kind of look at this technology and find out ways to actually make these agents test as they think and find a path forward towards trust. And then I'm going to talk to you a little bit about the future as we move forward with this technology. All right, so the evolution of agentic AI, and I think a big part of this is understanding that when we start talking about agents, sometimes it feels like folks position this as the newest thing in artificial intelligence. But this has been around since the 1950s, right? And I like to use a very timeless definition first to introduce what an agent is, which is an autonomous entity that can perceive its environment, determine what to do, and then take action towards its goal. So this autonomy can actually dictates, and you can describe this almost like an autonomous loop where you're perceiving, deciding, and acting. And this definition allows for a lot, right? It doesn't have to actually be some very sophisticated machine learning system. It can be very simple control loops, right? So I like to always give the example of a thermostat that is observing the environment. Very simple control loop. It's rules-based, but it is making a decision as to when to act. And of course, the actions there are just to turn on the cooling or turn it off or heat, I guess, depending on which climate you're from. But that's kind of like the foundational core of an agent. And we'll see how this has evolved. But I like to take a step into at least some of the foundational pieces of this and kind of the history of where this stuff came from before we get lost into the future, because we can build on those foundations as well. So this is Marvin Minsky. He's one of the founding fathers of AI. He co-founded the MIT Intelligence Project with John McCarthy, and so also co-authored the publication that coined the phrase artificial intelligence. And back in 1986, he wrote a book called The Society of Mind, where he looks at the research of the brain. And he says, basically, if you want to understand how the brain works, you have to start picking apart its functions, right? So how does the brain actually handle the body during different activities, whether or not we're eating, playing, or sleeping? And that by understanding those separate actions, you can now start to think about those individual parts, how they interact with each other to achieve this coordinated effort that rolls up into some system level behavior, right? And so this is a foundational thing in AI, because at the time of Minsky writing The Society of Mind, AI systems were built in a very monolithic way. In other words, you had a user interface, you had this like inference engine sitting on top of a vast number of rules, and that was like the standard of AI. And what the Society of Mind kind of introduced was like a new way of thinking about this, right? Like, let's see if we can have an agentic architecture where we have individual agents concerned with smaller parts, like lower levels of abstraction, and then have some supervision of those agentic capabilities, and now redesign and really rethink how we build AI systems. And this kind of led to what I call the first wave of agents. And there was a lot of different points of inspiration. First, biological and social systems all kind of use this idea of agents and swarming collective work. Distributed computing, of course, things like object-oriented programming. So understand that at the time, all of these things were going on, and this was what was driving this push towards these agentic or multi-agent architectural systems. And it was evident, it was quite successful in many different areas, from expert systems for identifying medical bacteria. Chess was a good example of where we combine search with rules and heuristics, right, to really beat human experts at something that they're doing, right? In this case, Kasparov and Deep Blue, we all know these stories. But also being applied to intelligent automation in industry, right? Different control systems and logic. So again, these are all rules-based. These are not these very elaborate machine learning systems. And so they did have some challenges, right? So understand that this first wave of agents led to a lot of these rules and quite some limitations when it comes to a number of things. The first thing was kind of the user experience that trickled in from using this, right? You had very limited choices. Here, there's a simple agent for, reserving a table at a restaurant, right? And so, hey, I'm here. I asked to book a table, and it says you can select from two options, right? So you're kind of canned into these choices, and the responses that come back are also quite deterministic usually, and predefined, right? They're following a script. The other thing is that this breaks down really, really easily, right? So if a user wants a reservation and a date exists, then book the table, right? If the restaurant is closed, then offer an alternative date. It seems very nice and clear as to the behavior that needs to be done. But what it doesn't factor in is the unexpected voice of the user, right? So what if I say I want dinner sometime after my daughter's recital next Friday? Does this logic handle that case, right? And it clearly doesn't. And what happens here is that there's very poor scalability. So every kind of new scenario, any kind of nuance to what is being said requires new rules, and it quickly explodes, right? From needing one rule to 100 rules to tens of thousands of rules, right? This exponential kind of growth. And what we realized here in this part of the evolution was that, hey, these kind of traditional rule-based systems, would be a lot better if the machines could actually learn their own rules, right? And so instead of having these very programmatic strategies, can we feed data to these machines, have them learn from that data? And so this is kind of the evolutionary step towards really this idea of machine learning agents. And of course, there's different flavors. Here is an example of supervised machine learning, where we're taking known patterns, feeding it to a machine learning algorithm, and then we're using the model that's produced to make predictions, right? And of course, this is actually very, very powerful. This is what drove a lot of advancements over the past years, where we could use this to do everything from identifying cats in a video to fraud detection, facial recognition. Things like recommendation systems are all built on this technology. And interestingly enough, I've been here before, right? That world was very close to me. I wrote this book back before there was ChatGPT, and it was because I was working on using those predictive machine learning approaches to build agents for automated software testing. So things like, computer vision for testing an application, or a whole domain of applications in the App Store. Doing hard problems and tackling things like testing video games using reinforcement learning, or looking at video streaming, right? So these were all agents that were based on machine learning. And, it's interesting how things have just kind of advanced really, really quickly, because now we look at these and we think, man, this is kind of older AI. And now we have like a new wave of agents that are all based on generative technologies. And this is kind of what brings us here today, is to talk about generative AI agents and this second wave. And the thing is that when we start to think about what happened to give us this like true evolutionary step, um, we unlocked a lot of what our natural language, processing techniques, right? So these large language models are trained on the natural language, right? Trained to predict the next word. So you kind of feed it and it learns to do this prediction. And again, that can be on a much broader scale, right? So think about complete sentences, think about things like code, right? And so now we have this natural language generation where we kind of train the machine on these large vast amounts of text from the internet, and then now we can use that as a superpower moving forward to not only generate text but also try to help us interpret what might be the intent of the user and be a lot more dynamic than those old rigid chatbots that we saw in the beginning, right? And so here again, even though it seems like, hey, we're just predicting words, there's a lot that comes along with that. And so where does this take us, right? We unlock this as an agentic superpower, and we stepped into the world of LLMs, but LLMs themselves weren't without some limitations. The first one is the knowledge cutoff, right? Like these models were pre-trained and therefore they're frozen at training time, right? Like, so whenever that cutoff date was, the model no longer knows any events, any prices, any releases, any facts that appeared after that cutoff date. So that was one limitation. The other side of it is that it was kind of sitting on its own. So it was purely like a conversational model. Like the first version of ChatGPT, you went to it, you talked to it, it was kind of sitting there on its own, and it could reason about that world, but it can't really see or fetch or act on anything in it. And even then, like this idea of reasoning about its own world is a stretch, because this wasn't really logic-based reasoning. This was really linguistic pattern matching underneath the hood, right? And so these limitations actually are important because it kind of led to the next step of this evolution, which is for us to say, like, yes, natural language gives us a superpower, and these large language models are very good for an agentic step up. But now we need to actually take these limitations and add to LLMs what would be some additional superpowers to really make them agentic, right? And so three main things that we'll step through quickly, again, just for positional context, things like document embeddings or agentic RAG, retrieval augmented generation, and the model context protocol. We'll step through each of these and just at least show how these capabilities really add to like what we consider today to be the modern agent. And so it seems very simple, but we had to ask the question, well, hey, we're limited by the cutoff. What could we do if we could give the AI its a document of our own, right? And so you start thinking about the process behind that. There's the documents themselves. We chunk them up. We create these embeddings, right? So these are mathematical representations of the meaning. And at the end of the day, once you do this and you store these in a vector database, similar concepts end up close together, right? So customer account billing, right? This is how a lot of recommendation systems search for the next show that is similar to what you just watched, right? But the whole example now is that nowadays we launch a LLM of our choice, whether it be ChatGPT or Claude, and we attach a document, and it just seems like normal, right? To ask it questions about that document. But underneath the hood, you're chunking, embedding, retrieving, and generating, and this is really the foundation for what is modern knowledge retrieval. And so that kind of built into what we refer to as retrieval augmented generation. However, this is not just that. Like typical retrieval augmented generation, retrieval happens automatically. Here, we're talking about an agent really driving and deciding what information it needs and then going and retrieve it, right? This idea of agentic RAG centers on the agent first, right? So it's not just the user is asking to like look up something and so on and so forth. And agent is sorry, and then we're going to retrieve some additional information before we go to the model. Here, the user submits the goal, and that might be something like compare our product requirements against the current market expectations, right? So this is very different from a simple query. Where do we get those current requirements from, right? Agent interprets that goal and says, hey, do I need internal documents? Do I need to go to the web? Do I need database records? Like, do I need a tool, right? It starts to make those reason about those decisions. And that first agentic step is what leads to the rest of this flow. So agent is really in control of that entire decision process. So agentic RAG, another step. And then last but not least, I think it all kind of culminates into what is the leveraging of the model context protocol. And this becomes more than being about data and retrieval. Here, there's access to the whole world because we're opening up the ability to like integrate tools that we might want to leverage, whether it be email tools, whether it be web tools, whether it be your own, APIs or capabilities. And all you need to do is kind of build and expose an MCP server like you see here. And now I can get calendar events, right? Or I can retrieve a brief of this particular project because I'm now integrated into that ecosystem, and I can bring that to the LLM and make all those decisions, from that point using the agent. And then last but not least in this is that true reasoning then also became a superpower. And there's lots of different, ways that we can look at the agent thinking. One of the first ones was this idea of chain of thought. This is very memorable because remember initially LLMs were not very good at doing things like math, right? And so you had to ask it to think step by step, right? Break down that reasoning for me instead of just jumping to a conclusion. And then it became better because it was kind of focused on that reasoning path. And then, you also had a good explainable result when you were done. There's also planning. So here is not about solving a problem, right? It's just about kind of organizing work. So the result here is coming back and saying, hey, if you have a complex task that needs coordination, I just need to understand the deliverables, the milestones, what needs to be done, and do that first before then going off and solving the problem. And then last but not least is something called react or reasoning and acting, where the agent takes a step and it sees like and learns something, and then it needs to decide what is the next move, right? So it's kind of this alternate reasoning and acting and using these feedback loops. And this is also very good for when you have changing environment, things that you aren't going to be able to predict. So this helps the agent to be very, very adaptive. And so all this culminates into these, superpowers. And if we revisit the definition of an agent, right? And so not a generic definition, but a more timely modern definition, we can start thinking about agents as autonomous entities that, yes, perceive and act in the environment. They need to be able to do that. They need to be connected to the real world. But they can also reason about how they're going to achieve these goals and apply these different thinking patterns and now direct activity towards those goals using models, tools, and knowledge at the center of this loop. And not only that, and this is what kind of gets us into today's conversation, it's not just about thinking and acting, right? It's about using that thinking and reflecting on its own behavior to actually make improvements, right? To look at the errors that it's making and try to adapt, possibly in real time, to like actually improving its own performance. And of course, still as a core part of this, these agents are organized with other agents in the hierarchy. And so you have this loop of perceiving, thinking, acting, and reflecting as part of this modern architecture. However, although this is a fully encompassing loop, what we normally have is a lack of focus on reflecting and actually making sure that things are the way that they seem, right? We seem to kind of go through quick, get results, and move forward. But we want to change that today in focusing on self-testing. And so the modern architecture of an agent looks more like this, where you have a model, you have tools, and you also have an orchestration layer, which provides the reasoning, memory, instructions, goals, and etc. And so why does this actually break down? Like, why does trust erode in this new world? And well, it's actually very simple. Like, traditionally, when we do testing, we think of, hey, we're verifying this product at this particular time, and we're signing off that we think, hey, we've tested it, we found these issues, we found this to work, we've done the best guesstimate, because it's still never sure, at providing a high quality product, and we ship that out there. The issue now becomes is that with these systems, what was shipped at that verification time, at that sign off time, is not necessarily what the system is doing now. You have this kind of continuous widening without code changes, because these agents are very, very dynamic. And I like to use the term that the agents do not stand still, right? Like the phrase. They're in continuous drift, and there's many types of drift. I'm just going to point out three very obvious kinds. There's drift in the model. We've seen like how a lot of this technology has rapidly evolved, but even as the models are pushed out there, model weights can update. You could have like dynamic fine tuning. Behavior might shift, and now the same prompt that you used to use gives different behavior over time, and what was passing yesterday is now failing today, right? And so the models are drifting. The tools are also drifting, right? So we just mentioned MCP, APIs, plugins, all these different sources, any kind of downstream services that are integrated with this technology are changing, and now the agent's actions can break as a result, right? Or at least mean something different than what they used to mean before those changes occurred. And then last but not least, like even the real world itself, right? The right answer is moving. So data, policies, user expectations, these things are evolving faster than the core oracle of this agent, if to say the least, right? And so because of this, like we need to rethink like our approach to testing. And this becomes really important, right? Because traditional techniques were built for a world that holds still, right? And these agents are not standing still. And so, normally in the traditional world, you have a fixed specification, the oracle, you have one right answer, you have static, very scenario-based, usually human or deterministically automated tests, and change is an exception that you want to catch. It is not the normal thing. But with agentic AI, this correct behavior is more learned, not necessarily declared. There's not a single oracle. There could be multiple valid outputs. And there's all this continuous like evolution and emergent behavior. And so change is more of a default, not the exception. And so the whole idea becomes like, how can we deal with this? Well, the only way that I can think of dealing with this is building testing into these agents, right? Can we actually develop systems that can test themselves? And it's ironic because I've also been here before, right? Back in 2009, I was doing my PhD dissertation in this building, actually starting in 2005, 2006, graduating in 2009. And that was on the topic of autonomic self-testing, looking at systems that dynamically adapt at runtime, that can change. And this all came from, IBM and Microsoft and other folks looking at the next generation of systems that can self-heal, self-configure, self-optimize, and self-protect, and coming up with what was really an agentic architecture, these autonomous managers that they call them, that were managing resources, they were sensing their environment, they were cycling around knowledge and doing monitoring, analysis, planning, and execution, right? All things that you can certainly map to modern agents today. And my dissertation was like, well, if we're going to do all this dynamic behavior, what about testing? Testing needs to be a core part of all of this. And of course, then these managers are there. How can you test them? And I thought, well, why not have managers that test other managers? And seems like a crazy idea. Seems like, when do you stop? but it felt to me like the only way that we can actually keep pace with what was happening here, even in a runtime environment dynamically. And it's funny because now, after a 20-year detour, right? I started this problem in 2006 as a grad student. And now in 2026, you realize that the loop was always the answer, right? Like the monitor, analyze, plan, execute loop that you see in that foundational work directly maps to the shape of the perceive and reasoning and planning and acting and verifying um, that we've seen in modern loops. And if you just add a verification step in the agent's loop, then self-testing stops being like this bolt-on thing, and it becomes part of how the agent actually reasons, right? And so, part of this is just to open up our minds to how do we move towards self-testing agentic AI systems, where we can start to think from the goal of the agent, from the context. The agent can now propose tests, think about edge cases and invariants, and that it wants to carry out, right? And so it can generate those testing ideas, make them very concrete, and then actually execute them, right? So it can now say, hey, what is the set of tests that I want to run? And it needs to make a decision as to which environment it's running. Is it running it in a live production environment? Even if it is operating in production, does it spawn some duplicate somewhere else and do it there first before doing it live, making changes live? These are all runtime decisions that need to be made. And then, of course, like some judge needs to evaluate, what was the outcome of that. There's not these golden values or very strict assertions. It becomes something that's a little bit more fluid in terms of, was it good and acceptable, or was it, bad and out of bounds for what we're saying, and then either retry or escalate what's going on. And so the idea here is, a self-testing agent will earn trust continuously by autonomously generating, executing, and evaluating its own tests inside of its own reasoning. And so trust is not a certificate that you get once and you have, right? Like from our sign off, but now it's a property that needs to be maintained as we go throughout this. And, I was just giving a training on agentic AI and getting into advanced reasoning, techniques. So things outside of the chain of thought, like things like reflection, which where chain of thought helps to create an answer, reflection is about improving it, right? So agent kind of reviews and critiques and improves previous outputs. There's the tree of thought. So now just instead of thinking on one reasoning path, can you explore multiple paths and start to go down there and choose the best path, right? And last but not least, self-consistency. So the tree of thought looks at different options. Self-consistency tries to gain confidence by seeing if multiple attempts to do something, like slightly different ways on doing the same thing, actually agree. And so all of these reasoning techniques, whether they be basic or advanced, are really testing patterns, right? These reasoning patterns are testing patterns, from chain of thought to planning to react. They're all testing patterns, whether or not you're now making each step very clear and testable, or you're actually doing review and building that in. These are all testing patterns. And so the path forward towards really trusting this is thinking about how do we leverage AI as part of the solution to this problem, right? So behavior needs to stay aligned with intent, and we have to be able to keep pace with that verification and not be outrun by it. And last but not least, like we have to make sure that certain policies and guardrails are being followed. And so this idea of self-testing agents, again, humans are guiding, AI is accelerating, but the learning is going to compound and the system is going to become more trustworthy over time. And what I'm saying to you is that the future is actually right now. Like I just came from AICon. I gave this talk. So I know Adam couldn't make it on talking about AI native teams. And so this is my kind of repay on that, where like there's a future that we're stepping into, which is not about the traditional life cycle anymore. It's about becoming AI native. And my whole view of it is that the future really belongs to those who can specify and those who can validate. Because in a traditional life cycle, you kind of had these handoffs. Whether or not you were doing agile or not, it didn't matter. Someone was going from requirements, building out a design and passing that off, and then developing, testing, deploying, and maintaining operations. This was the model. And we in the quality engineering space all remember the three amigos, because this was how we make sure that we bake quality in by having these stakeholders at the forefront doing what they need to do. And of course, we have like a Lego theme here for QAHub, and so I couldn't help myself. Also, there's three new amigos, and I'm not going to spoil that AI con talk because I'll give it a couple different places. But the whole point here is that there's a new life cycle that involves us specifying intent and then giving that to AI to just generate. And then there's still a validation phase, a governance phase, and then there's learning. Because the future of our discipline, the future of quality engineering is with AI, because the life cycle is just not just humans doing this stuff, and it's this specification driven development taken to a new level where we're specifying AI ready specs because they're going to go to be generated, and then we're going to validate and go through that cycle that I just mentioned. But the one big problem here is that at the end of the day, you're still going to hit a bottleneck that will probably be the human validation aspect of it, because AI will be generating at machine speed and humans will be validating manually, and that will just cripple the whole system. And so how do you get to a better place with all of this? Well, it's less about us doing it completely manually and more about us building testing in. And so we go from testing software to orchestrating these self-testing systems. And again, this is not just like us saying that, like, hey, the testers need to care about this. No, like, if we don't think in this manner, like, none of this actually works, right? It either produces garbage or you end up in a bottleneck. And so this is kind of my call again to push that if you are in this space and that you start to see a lot of these different techniques and how they can be applied and how testing can be a part of these agentic systems, I encourage you to contribute, because validation is not a phase in AI native delivery, right? It's a capability that we have to design into the system, into the workflow, into the platform to be successful. And so with that, I hope you enjoy the rest of the conference. I hope I gave you a lot to think about, and that if you are ready and willing to nerd out on self-testing, please feel free to reach out. Thank you very much.
Hi, Tariq. Super. Awesome. Thank you. Great job. The audience has a few questions. Let's discuss them. Well, Tariq, the first question: what are the main limitations or risks associated with allowing generative AI agents to generate and evaluate their own tests autonomously? And how can these risks be mitigated?
Yeah, so there's a couple of things that need to be kind of solved there that I didn't dive into. Number one is that when do you stop, right? One of the biggest risks here is that you get into this infinite loop. Diony Santiago gave a keynote on this, calling it agents all the way down, right? Of course, like machines, like humans are, can be fallible and can make mistakes. So this is also another big piece. But if you don't actually figure out where to stop, you could be cycling on endless resources before you actually get any kind of answer. Like anything else, there's also still biases that are baked in. But again, this whole idea of self-testing is to help accelerate the human validation. So if we are really being risk-based, there's heuristics that we can use to help us mitigate some of these things. So it's not that there's no hope here. There is traditional foundational testing techniques that we can use to kind of prioritize, like, hey, how much testing with AI should we do before this comes to a human? versus like, having the human just go at it right away. And then what might not need to be checked at all, right? And so these are powerful techniques. So, but great question.
Awesome. Next question. How do self-testing generative AI agents handle situations where ground truths or requirements change rapidly? And what mechanisms ensure that their verification loops remain relevant and accurate?
Yeah, this is also another great question. Again, this is a rapidly evolving world. And even when you look at some of the capabilities right now of agents, it requires us to be plugged into kind of current information, right? So again, all we're saying here is that we're going to flip this problem on its head. So while things are changing, the AI needs to somehow also be plugged into the channels where it can retrieve from different sources. What actually are those changes? What are those new trends, right? What maybe are things that have not been specified in my request that have changed out there, and know when to go out and use that as part of its own kind of thinking loop, right? Um, so uh, we have to be able to, I think, to make this successful, to answer that latter part, we have to be able to make sure that we are ourselves as humans looking at these current changes that are happening and helping to guide the machine on how to deal with some of these new scenarios. Like the challenge is that things will change and it might detect that change, but then it isn't really learning what is the expert way to handle that. And so it requires us as humans then to take our focus off of the nitty gritty of the technology itself and focus on the strategies for how you can tackle some of these things and feeding those to the machines continuously, right? So there's a level of training that's also going on in the background and modeling of the world and how to handle those things as part of this.
Wow, excellent. Thanks for your answers. Let's see the last question from the platform. In your experience, what role should human oversight play in the continuous verification process of self-testing AI agents, especially when dealing with emergent behaviors or unexpected model drift?
Yeah, I mean, I think that again, I'm a tester, so I always think about risk. If we're dealing with a system that is going to make or break, the bank of your business or maybe cause harm to a human being, human oversight, it has to be kind of the top priority, and you have to put that investment in there. When you're dealing with emergent behaviors, especially in risky areas, then we have to have safety mechanisms kind of built in to be able to shut off whatever that behavior or whatever that agent is doing. And then this also just brings up pure security concerns that, I follow a guy named Nathan Hamill, and Nathan really impressed me. I met him here in Miami at a conference event. We spoke together, but one of his things is talking about, like, trapping the inputs that are coming in, restricting the behavior of the agent, not giving it access to everything if it doesn't need access to, and kind of going in this kind of loop where you're making sure that you set the parameters and the bounds for AI. And so we need more governance. We definitely need more security procedures and humans at the forefront of that. We're still lagging behind, and we really need to bake all of this stuff into the platform itself. And as humans, be orchestrating it. So we need the tools to give the oversight. It's not just human oversight, it's human oversight powered by AI tools themselves, that we are on an AI platform that we trust.
Great, Tariq. Thank you for your inspiring presentation and detailed answers to the question. Your perspective on modern approaches to testing and the implementation of new quality standards in the era of artificial intelligence opens new horizons for the professional community. Thank you for sharing your experience and helping conference participants rethink the role of testing in a rapidly changing technological world. Guys, stay with us. There will be a lot of interesting things to come.
Please wait a little. We'll get back to you in a moment. Please wait a little. We'll get back to you in a moment. Please wait a little. We'll get back to you in a moment.
Hey everyone, we're pumped to launch an awesome competition for everyone. Score cool prizes such as bottles by completing the challenge. More tags and more chances to win. Let's do it. Good luck. And now let's welcome our next speaker, an experienced AI-first servant leader known for applying systems thinking to drive results across both engineering and business domains. With a proven track record of building high-performing teams and transforming organizational culture, our speaker excels in engineering efficiency, decisive leadership, and employee development. His expertise spans continuous testing and delivery, large-scale data architectures, and fostering growth and innovation within teams. Meet Melissa Benoit. Melissa moves on.
Hey everyone, good morning from the West Coast of the US. And we are going to talk today about when the signal lies. So we're going to go through some stories about things that are real, things that have happened, and talk a little bit about what those things mean for what's going to happen next. Because we all know we're in a very interesting world. What we learned 3 months ago is old and busted. Who knows what we're going to learn 3 months from now? And all we can do is build the systems that we think are going to do the best for us today, tomorrow, and next week. So we're going to start with a real painful, situation here. So many years ago, long before we were talking about AI developed code, AI assisted anything, AI was still a pretty niche thing. I worked at an early stage startup and we had a test suite. It used to test our virtual currency system. This was a gaming startup, so we built backends for games. It is now actually the backend for games you might have heard of. One of them is called Minecraft. It's a niche thing. I don't know. So we were building this backend and we were working on virtual currency, which was stored in the SQL database. And we started running into concurrent weird failures in this test suite. We would be making a change. The CI would pop up a failure and we would look and we would see, oh, it's fine actually. And sometimes we run the suite and everything passed again. So we're like, oh, the suite is flaky. We're really busy. We have a deadline. A customer's game is launching. We don't have time to go figure out why these tests are flaky. We just know that they are. And so what was there to do? There was just to keep moving with our flaky tests. And so we kept going. We kept iterating on this code, and every now and then these tests would fail, and we'd look at the CI and we'd say, me and my friend who were reviewing would say, oh, yeah, it's those same 3 flaky tests again. It's fine, just push. It's fine, just push. And this went on for a couple of days, maybe into a week. And we kept going. I had another change, same routine, flaky test popped up. We said, oh, it's fine, just push. But what we didn't notice was that in ignoring the same 3 flaky tests that kept appearing, there was a 4th test that also failed. But we had become blind to the failures. We said, yeah, whatever. I missed it. My reviewer missed it. We all missed it. And we pushed submit and it merged and a CI helpfully rolled it out into production. And then we got the alerts coming in. Alert. Hey, currency is down. Hey, nobody can do any transactions live in production. And we went, oh no, what happened? And it turns out there was a real failure. And because we had pattern matched on we can ignore these failures, we ignored a real failure and we broke production. Luckily, it wasn't irrecoverable. We could roll it back. We got everybody back up and running, in an hour or so. But it's not that we shipped bad code. It's not that we didn't test our code. We did. It's not that we weren't careful. We did have CI. But the system trained us to ignore the flaky tests, right? We couldn't trust the signal. So in the lack of trusting the signal, we shipped a mistake in the worst possible case, which is one we had tested for and one we had accounted for. And it told us there was a failure and we ignored it and did it anyway. So what's going to happen now, right? If that could happen 10 years ago, what happens now when you've got a team of agents and the team of agents are working through a build loop and they see a test fail? And the agent doesn't understand the test is flaky. It just says test failure, right? It's an input-output machine. And so it gets that test failure and it says, now what do I do? Oh, I better fix it. But it can't find the problem because there is no problem. It'll change the code. It'll get the failure again. It'll change the code again. It'll add more logging. It'll add more debugging. Change it again. Change it again. It'll start spiraling. And if you have this sitting in an unintended loop, you're going to come back to chaos. I'm sure some of you have experienced this already, right? Where the agent gets a weird signal, a spurious signal, and it just starts going in a crazy direction. The token counts keep going up, gets more and more and more expensive. The changes are less and less and less useful. But all the agent does is say, I have a red signal, I need to make it green. It doesn't ask itself, is this a good test? Is the test reliable? Its job is to make it pass. Right? It will act on every signal you give it. So the problem isn't effort, right? The agent works really, really, really hard. The problem is trust. How can you trust that the signals you're giving to your agent are going to result in a good outcome? And so that's what we're here to talk about today. Oh, that loaded well. That's okay. You can see my face here anyway. So we're here to talk about today. How do we build trust in our production systems? I've been doing this for, sad to say, more than 20 years. I'm currently CTO and co-founder of an AI-based startup. I manage teams and teams and teams of agents the way I used to manage teams and teams and teams of people. I think I managed more agents than I did people, and I managed an entire group. I was a VP of engineering previously at an ad tech company called Rocked. I've run platform engineering. I was an SDAT at Microsoft. I've done all kinds of things to help me ship systems, large and small, large scale, mostly large scale as opposed to small scale. And that has never been more important than today, which is you have to build systems that both people can trust and that AI can trust, because otherwise you're just automating chaos. In fact, that's what we found Vega to address the issue in accounting for how we don't automate chaos. And that's what we're going to talk about today. So we're going to talk about what breaks signals, how AI makes it 100 times worse because AI doesn't have any judgment except what you give it, and how you can then earn trust in your system so that you can then let your AI loose. You can run them in YOLO mode because you know nothing crazy can happen. It can only do what you want within the systems of what you want, and any of its choices are good choices. So there are 4 primary ways that a signal can break, right? They are unreliable. And if you've been in any of my tutorials, you know I talk about these in a slightly different way. But flaky tests, you cannot have unreliable tests. If you run the same code and get a different result, that is unreliable. It is non-deterministic, right? If your team says, oh, just rerun it, and usually that fixes the issue, that's a beautiful golden example of teams learning to ignore the signals of the systems that they've built. They're not investigating it. They know that the signal is not trustworthy, so they just don't bother looking. Likewise, if the signal is unspecific, right? Something failed. What failed? I got an error. What error? It timed out. What timed out? Timed out doing what? You have to have your signals be actionable. You have to be able to take an action. I got an error is useless. Doesn't tell you anything useful. You have to add more logging, you have to add more debugging, and if you have to do those things, that's what you need to do to make this an actual usable signal. Same for your engineers as for your agents. It has to be trustworthy, right? If it's something historically noisy, that everybody pattern matches against it, right? So if your devs don't want to run your test suite because your test suite is flaky, or they dodge around it, or they're very focused on how do I not run this, that's a great signal that your test suite is probably going to be a problem for the AI as well, right? A signal that nobody reads is wasted compute. And finally, it needs to be decidable, right? An undecidable signal, if a human has to look at it and use their judgment about what does this mean exactly, it's not a gate, it's not a useful signal, it's a request. And requests, you're leaving it up to the AI to decide, and that thing will change its mind every week depending on what's in its model weights. So a golden example of this, right, is visual validation suites. Not to say they're not valuable, but as a gate, knowing that something changed doesn't tell you if that something was good or bad. Yes, I added a button. That was on purpose. It changed on purpose. Or no, I didn't change it. Great, that's useful. But I added a button and it was on purpose. And is it a good button? Does it render where you want? It can't know those things. So if a human has to look at it and decide what your signal means, that's fine. Doesn't mean it's a bad signal, but it's not one you can feed into an AI. It can be very dangerous. Likewise, just like with the suite that nobody runs, it's very easy to fall into this trap about your vanity metrics, right? We all do them. Look, I worked at Microsoft. I, like everybody else in my cohort, shipped a test framework so that I could get promoted, because that was how you got promoted as an SDET at Microsoft. You shipped a test framework and you got everybody to use it for, I don't know, 3 or 4 weeks. And then they were on to the next person's test framework. So I understand writing vanity metrics, playing the game because you have to. But again, that's dangerous for an AI. Code coverage at 95%. Okay, great. Looks good, but it doesn't tell you if you actually tested what mattered. It just tells you that you sure did cover a bunch of lines. Did you cover them well? Did you explore your cases? It doesn't know, right? It's not a useful signal except in tracking trends, right? Much more importantly is, I added a bunch of tests. Would these tests have caught the last 3 bugs in the area? Right? Did you ship? Is there a bug in production? Do you have a test that would have caught that bug in production? The goal of a test suite is to catch issues before they get to production, before your users find out, right? That is the beginning, middle, and end, the full value of any test suite. Am I catching an issue before my users do? It's not the only one, right? Of course, a unit test suite or an integration test suite is not the only way you catch issues for users, but it is by far the fastest, and it is in its entire reason for existing. So rather than looking at code coverage, yeah, we have great coverage, or we covered all the APIs. Ask yourself, would this coverage catch the last couple bugs? Does it catch the last couple bugs? Have we updated it from the last few bugs that came in to ensure that we actually are going to catch the next set? Because that's the value in your test suite. Conversely, right, as we talked about earlier, a flaky test is worse than no test at all. So I would rather you have literally 0% test coverage and know it than pretend that your 95% coverage was covering good things, or that your flaky suite exists. Because if you don't have coverage, at least you know you don't have coverage, and you're more likely to be careful, right? We're very careful, at least I'm very careful when I ship untested code. I like to know, okay, we don't know anything. We don't know if it's working. It means I need to be very diligent, validating it myself by hand. But if we have coverage, and the more coverage you have, the more cavalier people will get about assuming, oh, the test caught it. Oh, the test will catch it. Oh, there's tests there, right? It's a psychological thing as a part input into your system. And even worse, if you have a flaky test and you ship anyway, like I did, it's the worst possible outcome, because you spent time, very valuable engineering time, right? Human time is the most valuable resource we have right now. And we spent, if we have a flaky test and we shipped a bug, we spent valuable human time optimizing, writing tests that we ignored, that were supposed to stop us from shipping a bug, and we shipped it anyway, right? It is 10 times worse to be in a postmortem or to have to explain to your executive, right, to your VP of engineering, to your CTO, not only did we ship a bug, not only did customers see it, but we had tests for this bug, and the tests failed, and we did it anyway, right? That is a very awkward conversation to have with an executive, with a leader, with your manager, right? It's one thing to say, yeah, look, we didn't test it. We couldn't think to test it. We had a gap in our testing. We're going to plug it up. No worries, right? That's normal. But we did test it, and the test told us there was a failure, and we did it anyway. That's, again, it's a very different magnitude of problem. And once you have one flaky test, right? Once you start tolerating one, the rest will sneak in. It's been a minute since I worked in an office. Well, it's been like 6 months. But it used to be, I used to joke in the office, I'm not your dishwasher. I'm not your mother. Put your dish in the dishwasher, because what happens? What happens in my house, what happens in the office. There's 1 cup in the dish. There's 1 cup in the sink. There's 2 cups in the sink. Suddenly the sink's overflowing and nobody put one damn thing in the dishwasher. It's the same with flaky tests. Whatever you tolerate is what you're going to get. So if you tolerate a couple dishes in the sink, you're going to get a lot of dishes in the sink. You tolerate a couple flaky tests, you're going to get a lot of flaky tests. I was notorious for my rule in my last role of saying, I don't care if your test is flaky. I'm going to turn it off. You have 24 hours. I'm going to disable it. I'm going to open a bug for you. You're welcome to re-enable it when it's passing, but you have 24 hours to fix this. I'm turning it off. Why? To avoid the worst possible case problem for them. I had a test suite, and also additionally, I shipped a bug to production. So when you have flaky tests, you have idiosyncrasies in your CI, it's fine. But remember that the humans who've been working there for ages and ages and ages have knowledge in their brains about what to do. That was handed down, whether it was tribal knowledge or whether you have beautiful onboarding docs or whether you have a good mentorship program, right? People onboard other people. They do knowledge transfers over days, weeks, months. The new people learn how the idiosyncrasies of the system work and they carry forward, right? They learn this error in the CI actually means the test database didn't seed. We need to run a clean database. No worries, I know how to fix this. The agent doesn't know that. Unless you capture that knowledge for it and put it somewhere it's going to get and make sure it's indexed and make sure it loads it correctly, right? The AI doesn't learn. The AI only knows what you have fed into it. Again, I'm assuming standard usage, not if you've built your own learning model into your AI, fantastic. But for most of us, the AI doesn't learn except the docs that you put in the repo, the information you stuff into it. So the AI reads this, and if it's not written down somewhere very clear, it's going to say, I need to go fix the auth service. Obviously, something is wrong with the auth service. And it's going to go in there, and it's going to write some changes, and they're going to be miscellaneous changes. Yeah, and it's going to be chaotic. So when you've got machines reading off your input signals, you have to make it so the machines can know what to do, or you have to make your systems durable enough that they know that the AI can act on them. Oh, I see we did great. I see all my images loaded well. Right? It's not the AI's fault that it ships a bunch of garbage if there aren't systems and guardrails in place to stop it from shipping a bunch of garbage, right? If your company, and many, many, many of us have, I have, right? If you've relied on human judgment and manual calls and manual overrides and manual gates in order to protect your production systems from bad code or buggy code, then it's your system that has the issue. Right? The AI didn't introduce problems with flaky tests. It didn't introduce that it doesn't know what to do, that your CI is vague. The AI only made those problems very visible and exposed them very quickly, made it very impactful. Right? These are not new problems. These are not the AI's problems. They are problems of the system. They were always there, but you got really good at covering for them with the human element, with training, with onboarding, with pairing. Those problems always existed. So what does it look like when you have a flaky test with a person, right? When the flaky test starts failing, the human developer just knows, oh, it's those suites again. I'm going to rerun it. I'm going to go walk around. I'm going to take a break. Great, right? The human knows how to stop the system. The AI, on the other hand, will say, oh, flaky test failed. I better fix it. Test failed. I better fix it. And in the time it takes the human to rerun it, go get coffee, take their time, chat a little bit, walk back, the AI may have done 4 or 5 iterations of, oh, better fix it. Oh, better fix it. And you're going to come back to chaos, right? The human developer pattern match. She said, it was those same tests. I know what they are. I know that I don't need to go start writing code. I know that I just needed to rerun. The AI doesn't pattern match unless you have given it a pattern. It doesn't pattern match that, oh, it's those flaky tests. I saw them 3 days ago. It doesn't know. It doesn't remember. So in the end, the human maybe lets a real failure through, but otherwise just reruns the build once or twice and we all move forward. The agentic code, on the other hand, is going to be full of stuff. Good stuff, bad stuff, a lot of stuff that wasn't needed for the change, which is very dangerous because the AI will produce, I don't know, 20,000 lines of code if you let it. The AI will produce just a great magnitude of stuff, assuming that it broke something, right? It acted on the signal. The human will pattern match, ignore, take a break, come back. The worst case is the human pattern matches slightly incorrectly and we ship a bug. The AI, on the other hand, will continue acting on that signal every time and every time and every time until either the signal stops or the AI somebody stops it or it hits, a speed bump, a limit. A lot of CI was not designed for agents. So clear, specific messages, an agent can self-correct. Right? Unusual message, the build failed, dependency updated. I don't know, maybe. The agent's going to guess. So LLMs are notoriously tuned for wanting to please you, want to generate an outcome, which will make you happy, right? Not which is correct, which will make you happy. It's a subtly different thing, but it's important. And if the task it has is make this PR pass, it's going to do whatever it thinks it needs to do to make the PR pass. Maybe that means blanking the tests out altogether. Maybe that means changing the product code, adding debugging, disabling the check. I've had to do that. Disabling the check. The check isn't reliable. I turned it off. I don't know what to do with it. Whatever you tell it to do is what you're going to get. So if the messages are clear, the signals are clear, the agent can self-correct. It can say, oh, yep, CI failed. This test failed. I can see why. I can go check the log or I can check the observability. Yep, makes sense. I can prep a fix. But if those things don't line up, if they can't be traced from one to the next, if the names don't make sense, if the messages don't make sense, you're going to end up, again, with some chaos. And even worse, right? We could have had that chaos problem with human developers, right? With your new intern, doesn't know anything, your new hire, you've handed a project to a new team, maybe they're not in the office. We could have had this problem before, but it takes time, right? It takes weeks for a human to do the same amount of work that an AI can get done, right? Instead of weeks of drift, right? When I shipped the bug, it was not the same day that we found the flaky test and shipped the bug. It was at least a week, maybe two, of drift impacting of our brains, pattern matching, and moving closer and closer and closer and closer to the incident. The agent can get there in, I don't know, an hour or two, an afternoon, right? Your change failure rate will rise, your bug escape rate will rise, because your agent will act on those signals really, really fast. I don't know. Hopefully some of you have moved past the chat level and into supervising authoring level. But if you haven't yet, I promise you, it's so fast. By myself, I can now write 3 or 4 full features, 10, 15,000 lines of code in a week. By myself. I used to take my teams, split, 4 teams of 5 people each, 6 people each, used to take 3 months to get that kind of output. And so if that's the output we can have, imagine what happens if the agent doesn't know what good looks like. All we're going to do instead is compress these patterns into incident after incident after incident. Again, you're going to be automating chaos. How do we stop this? We need guardrails. So the system and its signals form the basis of the guardrails that help the AI stay where it needs to go, right? Guardrails aren't friction. I worked with a leader, a non-engineering leader, who was very anti-friction. Friction is bad. Friction is in the way. Friction is slowing our AI adoption. We have to remove all the friction. And then they said, and why do we run all these tests? They're so slow. They're just unneeded friction. And why do we have this CI process? Can't we just get it into production? It'll be faster that way. To which we said, it's faster in the same way that if you run a train off a cliff, it will get to the ground faster than if it stayed on the rails. True. Yeah, that will be faster, but we will not perhaps arrive in the state with which we hope to arrive in. Right? The guardrails aren't friction. They're literally what keeps the train going. They help keep you safe and your code safe so that we can actually deliver an outcome, right? Because the outcome is not code. The outcome is not, congratulations, you yeeted 20K lines into production. Here's your gold star. The outcome is our customers are happy with our system and are able to solve their problems with it. And so if you're optimizing for yeeting code into production, great, remove the guardrails. If you're optimizing for solving customer problems, you need to reinforce those guardrails and make sure they are clean, beautiful, lined up, on track, and going exactly the direction you need them to go in. Because if your feedback loop is lying to you, AI will amplify the lie, and your guardrails have to catch it. They have to be strong enough to catch it. So every test suite has to have these 3 properties. Again, if you've been in one of my tutorials, this shouldn't be a surprise. They're non-negotiable. Every CI check, every test suite has to be fast, has to be reliable, and it has to be specific. Right? It has to give you answers in minutes. The fewer, the better. You have to run your most important tests first, right? If you build and compile, stop. If your TypeScript has a bunch of errors, stop. Don't try to deploy it. Don't try to run more tests on it. Stop. Get your quick results, take action on the first outcome, and then iterate. AI is great at iterating. There's no gap between the loops between I've found a signal, fix it. I found a signal and fix it. In the same way there would be for a human who would need to stop, think about it. Maybe you already got up, right? You're having sword fights while your code is compiling, while the CI is running. The AI never does that. It never does that. It's just available and waiting for the next input so it can take an action. So likewise, you need that action to be the same result every time. It needs to be deterministic. The AI itself is non-deterministic, so you don't want to put a non-deterministic system attached to a non-deterministic system. You're just going to get crazy non-deterministic results. Your test suite has to be deterministic. You've got 24 hours to fix it. You have to be able to trust the signal. It has to be the same result every time for the same commit. And if something does break, it needs to be really specific. You need to know exactly what broke, right? You don't want to know, test 9,304 failed. Well, great, what is that? What does that do? If you have to go open a manual to go figure out what's happening, that's not specific enough. It's not actionable enough. Instead, the test itself should say exactly what broke, what happened, what the test covers, so that the AI can very quickly and with a minimal use of tokens say, yep, okay, this applies to my change, here's how, or no, it didn't apply to my change, what should I do now? Since my tutorial, right, we've added a 4th property called decidable. So there is nothing more annoying to an AI than I don't know. You need very strong signals so the AI knows what action to take. Pass, great, we know a pass. A fail, okay, great, we know a fail. But what does yellow mean? Yellow in an automated system means a human needs to go look and make a decision. So great, sometimes that will be appropriate for your systems that you're testing. That's okay, right? I'm very pragmatic, very realistic. If you have a check and it needs to have a human look because we can't figure out if the visual diff is good or bad, we need to know if the tone is correct and we don't trust the AI signal, right? There's a bunch of reasons where you might require a human gate. Okay, great. But then that needs to be clearly labeled and it can't be in your automated CI that your agent is going to look at and make decisions on. You can exist, you can have them, but you don't want the agent unilaterally acting on those things. Likewise, in order to get to those very fast results, you're going to want a concentric suite architecture. I finally retired using a pyramid for this. Now we have concentric suites. You start with your smoke tests, your most dangerous code, the things that are most painful if they break. For example, can't log into the system. That would be a smoke test because you can't do anything else if you can't log into a system. Right? And you want to run those first because if the smoke test fails, stop. Don't continue. Do not pass go. Do not collect $200. And then you can move on to the next suite again, right? Okay, here's my full regression suite of all the things my customers are doing. And if that passes, great. You can run your selective additional tests, right? Security, performance, visual, anything that requires a human judgment or is very slow or it can be flaky, or we may have to make a judgment call on, right? You want to run those only as needed. The same with any manual testing, exploratory testing. People have been asking me for 10 years, Melissa, can we have manual testing in our fully automated CI/CD system? To which I say, yes, of course you can. I strongly encourage you not to make it the only source of testing, the only quality gates, but of course you can. And in fact, you still should. Even 10 years ago, in a fully automated CI/CD system, a human should always be looking to see, does this change work for our customers? Because maybe the AI is certainly getting better, but certainly 10 years ago, 5 years ago, the AI couldn't tell you that answer. Does this make sense? Does this look good? Is it working for our customers? Are our customers happy with this new feature that we shipped? A human still needs to go look to decide those things, right? A human has to look. But on the flip side, you probably don't have time for a human to be doing a full manual exploratory test run with every change to every PR before it's merged. That's very expensive. So where you can augment, move it up to an automated stage or have an AI do it, great. But yeah, you certainly can have manual pieces of testing or exploratory testing with a human applying judgment in any system, agentic development or not, CI/CD or not. So think of CI as your agent's manager, right? Your job is helping it figure out what it knows and what it doesn't, right? So the CI gives the structured feedback to the agent can self-correct, and they can go on this loop. And then your job at the end is to say, okay, did this make sense? Did it do something that worked? Did it write a whole bunch of garbage? Did it accidentally delete all the asserts out of my tests? So that's why my tests are passing. You ultimately own the quality for anything that has your name on it, right? You cannot fire an AI. You cannot send an AI to jail. You cannot hold an AI liable in court the same way you can a human. So ultimately, if you are providing a sign-off, if you are providing guidance, you own the outcome. So let the CI give signals back to your agent, and then that which frees you up to then provide the thing that humans are best at, which is providing the ultimate judgment on ownership and accountability for whatever it is you're trying to work on. Because those are the things a CI can't answer. Did these tests make sense? Were they high quality? Did they match up with the feature? Does the feature make sense? Does it look like it works correctly to an actual human? AI can't do those things for you. Likewise, test architecture is still your job. If you don't know what the largest quantity of corpus of information is in most AI training sets is, I'm unfortunately gonna have to tell you that it's Reddit. The average Redditor is deciding how to unit test. I don't know about you, but I think that I am probably better at testing than the average Redditor. So why would you outsource your knowledge about test architecture to the average Redditor? The basic stuff, yeah, sure, they'll get right. Unit tests, happy path, edge cases, sure, they can generate those, but what is your actual test architecture? Which flows in your system are important that become smoke tests? What boundaries fail under load? What happens from the last post-mortem? What is your application architecture? How do we tie your test architecture to it? What is our CI/CD system? What is our deployment mechanism? What regulations exist, right? Are we shipping medical devices, which are very different than shipping an app to the App Store, which is very different from shipping at the search engine? Shipping at a big company can be different from a small company, right? So all of these places are where your human judgment is needed to set up the right systems and the right architecture inside which the AI will work. Right? Because the AI doesn't know your system. It doesn't know how you work. It doesn't know your company. And if you want the average Redditor's opinion of how you should design those things, okay, good luck. But as of today, again, 3 months from now could be a different answer. But as of today, right now, I wouldn't trust its judgment to define these systems 100% on its own without my input, guidance, and control. So when can we let the AI own it, self-correct, versus when we need to actually put a human gate in place to say, look, you can't go through here. You're not going to understand. So the two questions I ask is, does this produce a binary pass-fail without human interpretation? Great, it can be on autopilot. And does this require knowledge that isn't written down anywhere that the AI can easily and readily access and find? Because access is different from finding it when it needs it. Great, if it doesn't need that and it produces otherwise a binary pass-fail, fantastic, it can go on autopilot. The CI can report on it. The agent will self-correct. It's a very happy loop. But if things require an interpretation in their results, or to get the right answer, there's knowledge that's in somebody's head, or that's captured in the team, or it's in the wiki, but the agent can't see the wiki, you have to have a human gate there. You have to have a human gate there, or you're going to get a problem. So things that go in the autopilot column: build compilation, unit tests, integration tests, linting. Are there vulnerabilities? Is there coverage? Smoke sweep pass? Great, that's easy. One note about code coverage. You heard me talk a little bit about vanity metrics and code coverage earlier. You should treat code coverage as a binary, ideally, and not a percentage, which is more, did you test something? Anything. It's more important to know that you tested something, anything, than it is to know exactly what percentage or aim for a target number. Because again, you're more likely to get low quality results when you're aiming for a arbitrary target number that's not related to your actual outcome, which is this thing works right. So the rule I have for every AI coding session is always, we're not done until the build compiles and all your tests pass. And I usually tell it additionally, you can't delete the tests to make them pass, because you know what the average Redditor does? The average Redditor will delete the tests to make them pass. So this is an easy feedback loop, right? All the pieces are input, and then the AI can easily iterate across these to make sure they work. I do it, I don't know, 20 times a day. It's easy, it's cheap, it's a low effort signal that results in much higher quality outputs. Does it mean that a given change is then correct? No, but does it mean the change works and is deployable and testable and, works at least enough for a human to pick up and finish? Yeah, it does. Right? Because all these signals feed back into a better system. I never, ever, ever will receive again, like I used to do at Microsoft in the bad old days. Cool, this is in C++ and it doesn't compile. Why did you hand me code to test that doesn't compile? Cool, it literally doesn't start. Did you write even one unit test? You didn't. Fantastic, it literally doesn't start. No, you will never receive that again from your AI if you set up these guardrails. on the other hand, places where a human needs to look. So if you need to look at a screenshot, the AI can tell you what's in the screenshot. It can maybe tell you if it aligns kind of sort of with your style, but it can't tell you is, are you sure that this was all intended? This was intended in the way that you intended it. It can do some exploratory testing, right? I do have my AI run its own change, use Chrome MCP, start navigating around the browser. And again, it will tell me what it clicked on, but it doesn't necessarily mean that it's easy for a human, right? It's better every week, but it's still not where I would say it's just exactly the same as I handed it to a human who deeply understands the system and made a judgment call for me. It's even weaker at architectural decisions, which is to say, if you don't put guardrails on it, you will get 4 different architectures mashed into one hodgepodge. Why? Because it will optimize for the minima and not always optimize for the maximum across the system. The better place to reserve human judgment is across the full breadth of a system, which the AI only has insight into a smaller slice. Same thing with acceptance criteria. It can give you some directionality to it. It can review the product spec and the requirements, and it can explore the browser and say, I think I matched it all up. But ultimately, that's a human's job to say, yeah, I understood the customer problem and this code makes sense. Same thing with flaky test triage, right? There's many, many potential causes of flaky tests, ranging from weird design, the environment itself is flaky. The test could be perfectly fine. The issue could be my CI environment has an old machine and the old machine has a failing disk, right? Doesn't mean a flaky test doesn't mean it's a bad test. It just means that something underlying the system is unreliable or has otherwise undefined behavior. But ultimately, we want to optimize for human time. Machine time is cheap. Tokens are cheap. Compute is cheap compared to human hours. So we want to make sure that we are putting as many human hours where we have high leverage and high value return, right? What questions can't our CI answer about this change? Is it good or bad? As opposed to doing low value things that the CI is great at, which is, does it compile? Did it pass unit tests? Did my automation all work? Right? Those are relatively low value things for a human to be involved in. The AI is getting quite good. Right? Your most expensive mistake is going to be wasting time on something that you should have found in CI, or burning CI time likewise on something that you absolutely needed a human to decide. Right? Just because CPU time and tokens are cheap doesn't mean they're free. So on the same time, while we're optimizing for human time, we don't want to be profligate with letting an AI go to a couple million tokens doing something that it cannot reasonably fix. You still need human oversight in the guardrails. It's a part of the system to make sure that it's not going to be automating anything too crazy, burning a bunch of tokens for no reason. So this one gets a lot of people concerned, but your implicit tribal knowledge was always bad, and now it's a huge liability, right? So the gap between what lives in somebody's head versus what's in the system, the bigger that gap is, the slower your system has to move, and the slower your AI agents are going to be, right? At agent velocity, knowledge is just a gap if it doesn't know it. It's going to be doing the wrong choices. So we have to take time to curate the knowledge that is in your code base, that is in whatever knowledge system that your agent has access to. It was important before, right? It was hard to onboard people if you didn't have a good knowledge base. But now it's very, 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 very difficult to onboard a whole team of agents. The good news is it's never been easier to do this, right? Give an agent a task. I have scheduled weekly runs that say, look across the last set of changes and go look at my knowledge base and make any updates, right? Did we ship a new API? Make sure those docs got updated. Agents are never bored. Agents never say, I hate documentation. Agents never say, nobody's going to read this anyway. Agents are great at doing those really boring tasks that nobody wants to do because, let's be real, nobody enjoys maintaining documentation. Well, very few people, because I'm sure there's somebody who's like, I love docs. Almost nobody enjoys maintaining documentation when your job is something else. But the agent is very good at it. Let it be good at what it's good at. But you have to get that information out of somebody's head. First and foremost, you have to have those learning cycles built in. All right. So when you're looking at your code base and you need to figure out what to ask it about your tests, here's my 5-question audit to start with, right? What tests are flaky? What has been failing in my CI that doesn't make sense? What test results don't make a lot of sense? You can feed a bunch of results into the AI and ask it these questions, and it will give you the answers. What results seem vague? What results are scattered and they aren't in a place that logically makes sense? They're not grouped well. What results does this agent believe are undecidable, that it can't make a reasonable choice? And where are the gaps? What hasn't been tested? And if you feed these 5 questions into your code base, plus a couple CI runs, plus, okay, here's my tests, you're going to find some very interesting results very quickly as well. And so once you have this information, what do you do next? So first thing is go find those flaky tests, kill your flaky tests. You have to kill them. Don't deprioritize them. Don't say we'll get to them next quarter. Kill them, quarantine them, get them out of your system. They are lying to you. Pick your 5 worst messages according to the AI, rewrite them. Let the agent do it, but make them specific enough that the agent believes they're actionable, that the message will lead to the agent making the right choice, right? You need your system to be self-reinforcing. Look at where your undecidable checks and either figure out how to make it decidable or label it as a human gate so the AI stops trying to act on it, right? And these aren't projects. These aren't, yep, let's schedule this. We'll work on it 9 weeks from now and it'll take 5 weeks. These are decisions that can be done quickly. You can kill your flaky tests in, I don't know, an hour or 2. Almost every test system I've ever seen has a way to quickly deactivate a test, right? Add a flag to it, disable it in the UI, whatever. Kill them, turn them off. Have the AI rewrite your errors. And the compounding action of this will increase the velocity of your system, which then frees up more time for you to improve the system, which increases the velocity of your system. This is a flywheel. This flywheel is really, really, really impactful. Getting this right makes a huge, huge, huge impact. And it was the same, again, it was the same 10 years ago. It made a big impact then, right? But it makes a bigger one now. You've been doing this your whole career. This job hasn't changed in terms of defining what corrects look like in the form of a system that can verify what correct looks like. This is more valuable, not less. We need this more than ever. We need healthy systems that give good signals, that are robust, that stop the bad things from happening at time, at velocity. Right? None of this is new. It's just that we put a new name on it. We gave it a new coat of paint, and we said, great, what if this went turbo speed? We gave it jet fuel, rocket fuel, and now we can bash 100 things through the system that could only handle 3. But this isn't new. Engineering fundamentals are not new. We didn't reinvent them, and they didn't become less important. Now that AI is here, they are more important than ever. So what can you do? What to do? Today is Wednesday. You've got the conference going on. What are you going to do on Monday? The first thing you're going to do is run your 5-question audit on your most important test suite in your most important code base. Feed those questions into the AI. Give it the result. Give it some CI results. See what comes out. I can't tell you what's lurking in your code base. I can't always tell you what's lurking in my code base unless I look. Excuse me. Go find your oldest flaky test and kill it. I promise you it'll be fine. Go kill it. Go look at your last 5 CI failures and ask, could an agent have corrected this? Could I have put an agent on here and could it have reasonably caught, either detected and preferably fixed this issue as well? Go look at your undecidable checks. Figure out what needs to be human triaged or not. And go find the gap in your tests, what they don't cover. Do you have alerts, right? So your observability and your monitoring is your backstop for what you're not testing. So if you're not testing something, that's okay. It's okay to not test something, but you better be really sure that you've got monitoring in place that will tell you. So what is your job now, today, in the age of AI? Your job is to design QA systems that earn trust so your team and your agents stop going off the rails and actually act on systems that mean something, so that you can build fast, repeatable systems that you can pipe 10x, 100x, 1,000x more code through than you ever thought possible. So that's what we have. Thank you guys today. I do have some of these things up in an open source repo called the AI DLC. If you're interested in learning more, I am accessible online. I have a blog series as well that you can find on LinkedIn or off my website. And I'm always happy to chat more or keep the conversation going. You're welcome to reach out on LinkedIn anytime. Yeah, thank you all. It's been a pleasure to be here.
Very cool. Melissa, we have received a few questions from the platform. Let's discuss them. First question. Can you share a real-world example where unreliable QA signals led to significant production issues, and what specific changes were made to restore trust in the system?
Yeah, so beyond the one we already started with, let me see what else. We've had that variations of that flaky test issue at least twice. There was a different flaky issue. So we had a certain type of test that couldn't run in production the same way it ran in CI because of a cache. And so same thing, right? We just said we're going to try to test it in in staging. We would test it, it would work fine. If you ran it locally, it passed every single time because by the time you were running it locally, the cache had always expired. But when you ran it in production, it didn't always work because the cache was in the way. Or sorry, in staging, it didn't always work because the cache was in the way. But we thought, well, because it's running low, it's passing locally, that must mean that it's fine. It must be some issue with the CI machine. So we're going to push it anyway. So again, the same problem. It always passed locally. We took an issue being serviced on the staging machine as proof that there was nothing. That the issue was a staging machine and not the actual change. Pushed it, and sure enough, there was a bug in the cache. That because of how the local config was and because of the time, right, the local machine was just slower than the production machines, caused a real issue. And so it was a production incident. And so the fix there was twofold, one of which was figuring out how to make the local machine look a little bit more like staging. And the other was being really clear about the error messages, right? It was a cache miss that was doing a thing. It was really difficult to debug. You couldn't grab it in the debugger. The log lines weren't helpful. And so it was a complex set of things. So first of all was saying, no, like for real, we don't ever ship over the top of a broken test suite, which was a process change, right? We said we just don't ship. If the test suite is broken, we need to understand why, and we need to make it pass or turn it off. But we don't just say, it's probably fine. So a human change. Likewise, a technology change of making it more testable in staging and making failure modes a lot clearer. Right? Okay, we had a cache miss. Make sure that shows up in the logs. Make sure that likewise you're getting the stack trace. You're getting all these relevant things. And so by making it easier, again, this was easy for humans. There was no agents involved, but making it easier for the humans to inspect, right? Because trust comes through inspection and validation and being able to close the loop on things. And so by making it more inspectable and making it more validatable, we rebuilt trust in that system.
Perfect, Melissa. Thanks for your clear answer. Next question. What metrics or indicators do you recommend for continuously auditing the reliability of QA feedback loops in large-scale environments?
That's a good one. So there's a couple signals. And the most important thing is not to take any one metric as gold, because as soon as you set one metric as your North Star, you immediately remove the validity of that metric. But I would look at several different signals. So bug escape rate is an important one, which is a little bit different from your change failure rate, but bug escape rate, change failure rate. I like to look directionally at code coverage. Not that I have a specific number in mind, but I like to know, is it going up or down? Or are we at 20% or 70%? Right across is a measure of tracking my team's investments into testing more so than the quality of it. How often I'm being asked for exceptions. Again, I'm notorious for not approving any exception, and in fact, making it obnoxiously slow to request and get it versus just doing whatever it is to make the system pass properly. So exception rate, how many times am I being asked to bypass checks? That should be very close to 0. Audible QA loops. I think those are primarily it. Yeah, change failure rate, bug escape rate, code coverage directionally, and exception ask rate. Because if your exception ask rate is high, something's wrong with the system.
And let's see the last question. How do you balance the need for rapid delivery with the rigorous validation of QA signals, especially in fast-paced development environments where time to market is critical?
So these things aren't unrelated. They're tightly intertwined, right? You cannot have rapid delivery without well-validated QA signals. You can't have one without the other, unless your job is just to ship a whole bunch of hot garbage, which is probably not what most of us want. We don't want to generally ship a bunch of hot garbage. We want to ship actual solutions. And so what I find is I need to work on my QA inputs when I find that that is becoming my long pole to getting an implementation out the door, right? So whatever the worst long pole is of my system, right? So as I'm working through a change, or as my team is working through a change, what's the slowest thing in their way? And that will change, right? Sometimes it will be the agentic system. Sometimes it will be the CI. Sometimes it will be quality. Sometimes it will be deployment. So every month looking, okay, what was our long pole? What was slowing us down? And what would we need to do to make that faster? And then making a practice of always putting in a couple little things to identify the long pole. And so if you have a solid, stable system, this broken windows approach can get you pretty good improvements. If you don't have a solid system, then it may be worth investigating, which many of my companies have done. What happens if we take a month and really work on making the system both human side, right? Training. Does everybody know what they need to do? Do they know how to take advantage of the latest AI tools? Do they know what we have available? Do they know how to build with it? Do they know what the system does? What the system does now, what the system needs to do next? And really putting time into making the system itself work, because it's a flywheel. The faster your system goes, the faster you can get changes out, and the faster the system goes. But you have to start. But it's best to start by starting.
Excellent, Melissa. Thank you so much for your insightful answers and for openly sharing your expertise with us. Your willingness to dive deep into questions and provide practical knowledge is truly inspiring. We greatly appreciate your contribution to the summit and the positive impact you've made on our community. Your experience and openness help us all grow and move forward together. Guys, if your questions weren't answered, don't worry. Our speaker will respond to everyone in writing as soon as possible.
All right. Yeah. Thanks, everyone. Appreciate it. Enjoy the rest of the show.
Folks, don't miss out on our special challenge happening on social media. Check out our channels for more details and get involved in the excitement.
Please wait a little. We'll get back to you in a moment. Hey folks, we're happy to announce a fantastic competition for all attendees, featuring great prizes for those who complete the contest term. The only condition is to tag us and submit on any social platform, and then win a prize. More tags, more chances. Good luck. Let me present our next speakers, but before, let me remind you about the social media competition. Tag us and this summit on any social media platform and win great prizes. Please welcome a technology leader and strategist with deep expertise in driving innovation and digital transformation. With extensive hands-on experience in the Ruby development ecosystem, our speaker excels in building and scaling quality engineering functions, developing automated QA solutions, and leading agile delivery. Their background also includes consulting, web analytics, API testing, and advanced security assurance for embedded systems.
But Jan is not performing alone. He has a wonderful assistant, an experienced quality assurance professional with over 10 years in the e-commerce sector, specializing in agile delivery and diverse development tools. With a proven track record at leading companies like Zalando, Notebooks Billiger, and Lionbridge, our speaker has successfully managed large localization teams, driven digital transformation projects, and consistently delivered high-quality results across multicultural environments. Meet John Schwenzin and Francesca Morando. Guys, move on.
Hello, everyone.
What an introduction.
Couldn't be better. Thank you, everyone, for joining. Before we begin, we would like to remind you that asking questions in the chat is welcome and encouraged. So, let's start. Our goal today is to reframe how we approach AI in the quality insurance space. I think we can all agree that we're living through the most dramatic acceleration in software history. As the AI is rising and it's completely rewriting the rule on how we build technology. Here at TPAM and across the entire global tech landscape, generative AI has made writing code, generating features, creating pull requests incredibly fast. But as we are accelerating development, we are facing a hard reality. The speed of creation has now vastly outpaced the speed of verification. And that brings us to our first problem, QA becoming the bottleneck. Maybe I will just wait a minute until we load the slides. So the topic is, while AI can write code in a matter of seconds, reviewing that code, validating the user experience, and testing the application still rely heavily on the human interaction. So developers are pushing code faster, but QA can't keep up. So even if our team are running as fast as they can, they simply cannot manually verify all the features at the rate the AI is generating them. That's the first problem that we face. And the second issue is that we rely on the traditional QA architecture as we know it. So on one hand, we have manual testing, which is highly flexible, understand the visual nuances, and brings human reasoning to the table. But manual testing is slow, is expensive to scale, and it fails to keep up with fast-paced release cycle. On the other hand, we have traditional test automation, so frameworks like Playwright and Selenium are fast to execute, but once they're built, but they are brittle. So these scripts rely on selector, DOM path, as you know. Even a tiny visual change like moving a button a few pixels or changing an element ID can break the entire test suite. This creates an extensive maintenance loop, and it has been estimated that QA team may end up spending 30 to 40% of their week rewriting broken script instead of automating new features. So automation runs fast, but maintenance can eat up more time than the actual testing part. So we have all faced these issues, and we realized that we didn't need faster scripts, and we didn't need yet another piece of testing software. We needed a truly agentic solution. Can we move to the next slide, please? Thank you, Jan. So while developing agentic QA, we had in mind the goal of bridging the gap between manual and automated testing by introducing an autonomous AI-native testing colleague that does not just execute static code, it reasons. So we were finally able to combine the speed and consistency of the automation together with the visual intelligence and adaptability of manual testing. And with that, I'll hand things over to you, Jan. Thank you.
Thank you very much, Francesca. Yeah, and thank you for talking over my technical difficulties. I had to rejoin. Now, the topic of this call is actually about how to treat agentic systems. And yet we have now started to talk about a specific agentic system. So I would like to start first by leveling with you kind of what we are even talking about here, before then going into what we mean by working with these kind of systems differently from how you do this with traditional software and why it matters so much. Now, first of all, in simplest terms, an agentic system would be one that employs more than one agent to collaborate on getting some kind of job done. What these different agents actually do depends heavily on the kind of system that you're looking at. You could, of course, think about talking to ChatGPT and simply giving it more and more context, more and more information, maybe access to files, access to some tooling even to perform actions for you in order to achieve some grand goal, some complex behavior, even scheduled or iterative behavior, self-learning behavior, if it comes to that. But it turns out a much better approach is to have multiple agents that have a smaller scope, that have limited visibility into certain context or different skills they might need, and have them collaborate with each other to actually accomplish a goal. It is a different level of complexity than what LLMs do on their own, to actually chain them and to let them collaborate with each other to perform complex tasks. Now, the way you would approach that in any agentic system is not necessarily the same. It's most of the time even not the same. There might be some commonalities in terms of you want an agent that can plan ahead. You would like to have an agent maybe that is responsible for memory, maybe long-term, short-term memory. But a different approach, similar but different approach, which we in fact took with agentic QA, was to look at how humans behave, how they think, and try to mimic those different parts of those voices, you could say, in your brain and how they influence your decision making. Where does this come from and why did we take that approach? Well, frankly, EPAM has purchased a company in 2019 that was already more than a decade has more than a decade of activity in the crowd testing area. So we are talking hundreds of thousands of testers around the world that perform software tests, functional, accessibility, usability, all sorts of tests, both scripted, following test scripts based on maybe user stories, or fully exploratory. And with all that data, the millions and millions of bug reports, execution documentation, but also interviews and simply talking to them, we try to learn how they do it, how this, especially successful ones, do their work so successfully. And we did this quite deliberately in order to figure out how far can we push AI to do the same, expecting it to fail. We expect to not get very far. Maybe there are one or two different things that AI agents might be successful at replicating, but surely not everything. But here we are today with what we call agentic QA. That is, in fact, the entire story. From exploration to, in fact, test script following, adapting to changing conditions and environments. It's the entire cycle. And the way we did it was by literally looking into the activities that are happening in their minds, to be frank. For example, when you do some new activity, maybe even some bold activity, like a bungee jump, right? Between your decision to actually do that and you doing it, there will be other voices in your head. You will hear a voice questioning your decision, right? Giving you all the reasons this might be risky or not a good idea, or maybe stories and memories of examples where it went wrong. So this kind of second voice in your head is just one example of the kind of agent that we employ in here that is second guessing decisions and pushing back on decisions made earlier. But there are more than 10 agents, in fact, this is just a symbolic picture here, active in trying to make the right decisions, evaluating results, rethinking the past, summarizing or extracting information out of what was observed, and so on. I will show you a little bit of that. But really, my whole point here is that we are mimicking human behavior. And this talk is all about treating agentic systems like colleagues, like humans, like employees. But we are not saying that they are. Right? Nobody is saying that these agentic systems actually are the same. So we did this little comparison here. I will just go through it kind of on a high level. I hope that works. Of course, you can look at agentic systems like that in terms of their raw power. They can do parallelism like no one else. They can do a lot of work in very short amounts of time. At dexterity, they can be precise. Yes, they can react quickly. They can do pixel perfection, and they can do this much, much faster than humans do as well, most of the time. It should be obvious when we think about constitution that such agentic systems don't need vacation. They don't get sick. They can work a long time. When it comes to intelligence, it becomes a little bit more interesting, though, because clearly nobody is saying that even agentic systems employing multiple agents, maybe even from multiple models, are actually as intelligent as humans. We're not talking about general artificial intelligence at all just yet. However, when you get to the point of not being able to distinguish the results of software testing activity in terms of was this done by a human tester or was an agentic system actually active here and did the agentic system make reasonable decisions and adopt it to changing circumstances? If you can't make out the difference, then for all intents and purposes, in this context of software testing, well, the agentic system is acting on the same level as manual testers, for example, would. However, if you go further and you look into wisdom, what we call wisdom here, like intuition, judgment, cultural context, if you look at especially modern times, at pop culture, for example, references, humor, frankly, and sarcasm, there are a lot of different aspects that agentic systems are not good at as of today. This can matter a great deal because context matters in many circumstances, and we need to be aware of these kind of limitations. Now, this becomes even more apparent when we look at charisma, which goes far beyond the operational activity of testing a piece of software. This is about rapport with stakeholders, and in fact, judging reactions and the meaning of human generated content, like, for example, comments, the right way and putting it in the right light and context, and then being able to even interact, maybe ask for information, create trust. Right? Having trust in agents or even agentic systems is a whole topic on its own that we don't need to go in here, but I think it should be obvious to anyone that it matters and that this is a huge gap we have today. So all of this is to say, no, we are not saying agentic systems are actually behaving like humans or they are the same. But what we are saying very clearly is you should also not treat them like traditional software either. And the first question here is maybe, well, why? Why does it actually matter? I mean, agentic systems are built with user interfaces, maybe APIs, maybe MCP servers. They very much are seemingly to be operated like any other piece of software. So before we go into the how should you act different with them and how you should treat them differently, let's answer that question of why. Well, let's first look at why not. What happens if you don't? And the claim here is quite simple. Just like an employee, you are behaving towards like a machine. These agentic systems will perform according to neglected employees' performance as well. That is what you will get over time. Again, the claim is based on the same expectations you have towards employees or colleagues. If you just expect magic to happen, if you don't provide feedback to them, they will perform less and less, with less and less return of investment for what you give them. If you communicate poorly in the terms of AI, we commonly talk about prompting, but it's really a little bit more than that. If you don't provide training to a human as to an agentic system, they will not perform as well. The results will actually decline. And you would never do this to humans. You would not want to treat them like machines. Most companies don't, I hope. And so you shouldn't make this mistake with agents either. Now, what does that mean more specifically? When you think about traditional software products that you might buy to solve a certain problem and you integrate, first of all, of course, you set them up once, you integrate them once, and the way they're set up is how they will work until you touch them again. Usually, you look at almost anything they do in terms of it either does the job that I wanted it for or it doesn't. It either sends out the emails to all my prospects or it doesn't. And it generates the report or it doesn't. Of course, there are nuances, but ultimately, you're looking at it in a very deterministic way, and you're expecting deterministic output. The same input, the same things I did, it should work the same as it did last time and not make mistakes. There's also no reason to consider any kind of traditional software to not perform immediately at 100% capacity. Why should certain features not work from the start? They have already been built. They have already been investigated, planned, designed, and built, so they should work. And ultimately, all of this together, you're buying some form of fixed feature set that only improves when software gets updated, which of course in a SaaS world is happening quite often, but that's the mechanics of it. Now compare that to agentic systems, right? They have the power to decide on their own how and how much they might integrate and set up these kind of connections. They highly depend on how you communicate with it. Now, this is maybe a little bit of a simplistic way to go at it, but the old adage, garbage in, garbage out, is of course what matters here as well, but it's not even what we're talking about. We're talking about, in fact, how you talk to it. You can describe, for example, instructions for a test that should run by giving step-by-step instructions of what should be done. Or you could describe the goal that should be accomplished. Why are we doing this? What are we trying to actually prove works or doesn't work? What is the goal that a user would want to achieve and why? Those are kind of the same. You are asking to do the same thing at the end of the day, but you're doing it in very different ways. One is more on the micromanagement side. One is a goal setter. This matters, and it matters a great deal in how these systems perform and if you get the kind of results you want, and if you have to micromanage these kind of systems in the future or not. Then you onboard and train. You don't just grant access like you would a human. You also provide some onboarding material, some context for the models that are active inside agentic systems to make the right decisions. But that doesn't happen immediately. You're ramping all of this up. So the capability of reasoning well will depend on learnings over time. Every time an agentic system becomes active, something will be added to its memory. It will have learned. It will learn from your feedback, from your training, and ideally from ongoing training. So it doesn't work 100% from the start, and that's very much by design. Your feedback, help it learn. Very fundamental and important issue here. And finally, you also want to take advantages of what's happening out there in the world. Just like if you have an employee using a certain piece of software and the software gets a new feature, you would like your employee to learn about that feature and then take advantage of it and use it. That's the same way you should think about agentic systems. As LLMs become more powerful, more tools are created, accessible via MCP or otherwise, that all of that really matters. So training it, teaching it, and the way that technically works most of the time is by granting access to more tools, to different data sources, more context, but also by changing the way of how you talk to it, and sometimes really just the tone. All of these things are vastly different from how you would think about interacting with a piece of software. Now, I try to make this a little bit more concrete, but it's still rather theoretical. Right? We are still talking about a mindset, a way of communicating. Let's actually look at a little bit of software. Let's look at agentic QA as an example of agentic systems in particular. And I will have to go a little bit into detail on what it actually does before I can then show you examples of how it, oh wow, and it logged me out. That is perfect timing. Okay, so I will log in again and then continue, but I will talk in the meantime. We will look at the functionality of what it can actually do, just for the context of what that means in terms of how you should interact with it. When you interact with it, you still have to use computer software interfaces. There is no way around that. And when you do that, and when you use these interfaces, then you will think about a deterministic machine. You will enter data and different kinds of data points and statements, which will in fact make you feel like you're talking to a deterministic machine, making it behave exactly as you told it to. So it is a true mindset change to figure out how to do this differently, how to go about it in a way as if you're talking to a colleague. This is new to everyone. And for most people, I would then guess it is very weird and awkward to do. It's kind of like role playing at the start. But I can tell you that this changes a lot as you start to see the benefits of it and you start to see the results of actually doing that over time. All right, so I'm ready to share my screen again. I apologize for that delay, and we can continue now here. I hope you can see the screen. Now, what you're looking at, first of all, is, yes, a web interface, like any other software. In its essence, what we want to do here is we want to go from some natural language instructions, that could be test cases, they could be user stories, they can have any kind of level at first, to our result. We want to understand, does this kind of behavior work? It's a very simple example here, granted. We don't want to know how it works, but also what was actually done, what was observed to give us the conclusion that it worked. And at the core of this agentic system is this kind of loop of planning, executing, and learning. So we are acting in step by step, every step along the way, figuring out what is just the next immediate thing to do in order to get closer to the goal of what we want to achieve here, to open a model for a new lead in this case. So we are starting on a certain URL. In this case, we are talking about a web application. We will see more in a second. And we can already see even a video of the agentic system performing this kind of action on the website. We have a before and after screenshot as well to have that in a static version. But most importantly, we can now see what it was thinking. Here's the action it wants to take. Here is the reasoning for why. And then I did mention this before. We already see another AI agent active before anything happens, evaluating if this decision, if this action is actually right. That kind of guard, AI agent here, we call it the guard, has a different kind of context. It looks at a different kind of context in terms of the history of what was tried before, of the memory from previous runs and all of that in order to make these kind of decisions. I might say a thing like, you tried something similar 2 times already, maybe do something different here. And this repeats over and over. Next, of course, it will want to enter the password. It just makes sense. It will then click login. And then we are actually arriving at an impasse, because now we have to fetch some authentication token from an email that was sent to us. This is starting to become annoying. So now you see that even with the simplest examples, you can't simply work with tools like Playwright alone. You have to now think about, how do I now access my emails? Could be a web interface, could be an email client. Wait for an email, retrieve and extract the verification code from that email, and then actually continue and move on. This is just starting to show you how all of this is going slowly beyond simply what you could do locally on your computer. And we will talk about that a little bit too. But it really is one of the most powerful concepts, because it shows an architecture that is based on building new tooling, new workflows, and agent orchestration dynamically as it is needed based on your use cases, and going far beyond just the limitations of a certain environment. Now, all of this, of course, works like it does here on the web, but it really is not limited to it at all. So I'm suspecting that possibly it will not load here, but we can also work on iPhones. We can work on device farms, EPAM's own MobiTrue device farm being an example here. Beyond that, however, we should now take a look at the interaction. So this is all nice and good. This is all about what agentic QA can kind of bring out of the box and the reasoning skills that the different agents employ. But the real interesting part comes with, how do I now work with the system? And we are starting by simply thinking about how to provide feedback. Now, normally, if something would happen here that we don't think is right, something that could be done maybe more efficiently, or it was simply a wrong step to take, we would think about, how do we amend our test case? And if our test case didn't specify a thing, or it gave the wrong instruction, something was missed, then we can't expect a manual tester, just as an AI, to necessarily draw the right conclusion and take the right action. So we would probably think about, how can we write better instructions? Now, again, with a human, with an employee, with a colleague, would you do that? If they did something wrong, would you go there, grab their laptop and say, let me give you different instructions? You would probably just give them feedback. You would write a single line saying, hey, I saw at this point you scroll down. You don't need to scroll down. You can click the button at the top left right away. It will just work, right? And it can be done faster. That is the kind of feedback you can provide here. Again, very much like to a manual tester. And what will happen is this entire check gets rerun with your feedback in mind. And with that feedback in mind, no new check is written, no new test case is written, but we have a better execution. And after that, we can in fact ask the AI, the agentic system in this case, to help me rewrite this check of mine, considering what was learned, not only by observing what happened on the platform, but also given the feedback I added to it. Now, looking at this, my God, I really locked myself out of everything. I will have to rejoin this one again. I'm really sorry for that.
It's always the case.
This is the real world and life experience.
It's by design, so when you stay too long on a session for security reason, it logs you out.
Exactly.
That's why we build this way.
Indeed. So we are looking at check suites now, right? Those are checks that have been written and generated. In fact, we can look at different suites we have in here and in fact go into an exploration mode. We can ask the agentic system to come up with useful checks, but more than that, we can even say, hey, colleague, could you go on and just explore the application, look at the different features it has, the different functionalities, forms that might be in there, and key functionality really, and please come up with a series of checks. Like write your first initial checks that could become the basis for a regression suite at some point, for example, yourself. We can also provide this kind of input, or in fact connect all of this to an existing source like a Jira system to fetch specifications and documentation in order to generate these kind of things. But no matter where it comes from, and if you asked your colleague to actually explore on their own and become proactive, or if you wrote something yourself, or if you transferred it from somewhere else, eventually you would expect a colleague to look at what was maybe generated or written or copied and think about if it could be improved. That is what you see here. We even have the reasoning to understand proactively without even asking for it. An agentic system will do things like, read the kind of input it got and conclude, well, this is more like a manual step-by-step procedure that was described here. We should be goal-oriented. We should rewrite this, actually make it shorter to have a more goal-oriented approach at what should be accomplished versus describing how. This is very similar to thinking about traditional test automation in relation to such systems. In traditional test automation, you also have these very precise step-by-step instructions. The step-by-step instructions, however, have to know about implementation logic. They have to know too much about how exactly buttons are positioned at some times, or IDs of elements to identify them. Things that don't actually matter to your users. They only matter for testing, and it makes them break very fast. So those are the aspects that you get around here. and that you can let your colleague help even proactively by listening to them or providing, again, feedback to them about what you don't agree with in order to improve. So with the risk of getting to the next tab that might throw me an error, yes, of course, there is more. So let me actually jump in it here. If we look at a little bit of a behind the scenes, we can see that there is a lot more when it comes to now dealing with shortcomings potentially or missing capabilities with such systems. We have a concept called toolboxes, which might be familiar because it refers essentially to MCP tooling. Many of you might be familiar with Playwright for browser automation. MobiTrue, I showed a little bit of something about using a device farm. But there are others, like two-factor authentication, token generators, memory management, talking to a file system, downloading and uploading files. The toolboxes are an essential part of this, and I think many agentic systems, on how you teach new skills. However, when you think about teaching skills, you normally want to do a little bit more than that. You want to not just provide raw skills, raw tools, you actually want to go into describing the skills and when they're useful for what kind of circumstances. Why is that important? Because imagine if you would have an employee, a colleague, that you just dump all the knowledge and information on. Just make them attend every learning course there is in your company or outside, every conference, read every documentation, learn anything from engineering to sales, because the more they know, the more skills they have, the better they will perform, right? Of course not. That would be ridiculous. And it is just as ridiculous to do the very same thing with agentic systems. You have to be selective about this. You have to have dedicated agents that have certain skills and they do not get distracted or start hallucinating based on some random information about unrelated skills for their current task of work. And the same applies here with custom workflows, custom toolboxes, custom agents that are configured even towards different LLM providers to really use the kind of skill that is right for their particular tasks, but also graphs that orchestrate all of these agents that are specifically built for different kind of tasks. We are now talking about a really in-depth kind of training, coaching, and extending of capabilities of agentic systems, most of which actually can be done in interfaces. Very little has to be done by engineering. So this is really the core of it. While in an interface, you work with such a system very much like you would provide feedback to humans. You listen, you react, you give feedback. Going deeper into such systems about how they learn, how you would find the equivalency to sending them to a training course, how to make sure that they use the right skills in the right context. Those are the kind of activities you do in agentic systems in order to make them perform really well. Now, all of this is, of course, a small subset of what you can do with these systems and how far you can bring them. But before we go maybe into how far you can take them at the end of the talk, let's come back and let Francesca challenge a little bit of what we have seen so far and what I've talked about so far.
Thank you, Jan. So now that you met our AI colleague and you've seen the scale of the solution, let's look at some real-world examples and challenge the capabilities of agentic QA together. So in our first example, we touched it together briefly previously. So let's imagine I am in a team with good automation coverage. I have a big project. We have maybe 2,000 regression tests already automated, right? It runs fast, but it breaks easily. And we spend a lot of time investigating false positive and fixing automation script. Now, my question is, how does agentic QA compare to traditional automation? And how does it help me and my team in this case?
Got it. I'll actually stop my screen share for a bit there while answering this and prepare a little something. But in the meantime, let me address it. Now, I started addressing this, in fact, in a slight way. I started to talk about how you compare agentic QA to traditional test automation in terms of figuring out the speed factor in maintenance of regression suites and so on. And this is kind of an important thing. It is very easy to compare agentic QA to manual testing. Right? In the same amount of time, a lot more can happen. It can also happen day and night, and the reasoning skills are really on the same level. When you talk about traditional test automation, you will never have an agentic system work as fast as traditional test automation does. This is very much by design. You effectively can't. And the reason you can't is quite simply because following orders blindly will always be faster than actually thinking about what you're doing and why you're doing it. This, I think, is a universal matter of fact, and that will not change, no matter how much we optimize and how fast we get. However, if you look a little bit beyond this, if you go into the question of, well, how much does it actually cost to do everything, not just writing test automation scripts, running them, but also maintaining these regression test suites? How much does it cost in time and money to fix broken and flaky tests? Because again, these test scripts rely so much on implementation logic, on overly precise knowledge about how interfaces are built and where stuff is placed, instead of being goal-oriented. Then the picture changes entirely, right? So agentic QA is not supposed to even be a replacement for all things automated, not at all. But wherever there is any significant amount of change still happening, to have a system that can actually reason and adapt to those quickly changing circumstances becomes much faster and cheaper if you count in all the different steps, including the maintenance, healing, and fixing of broken tests and so on in the equation. That is how I would encourage to look at that. And hopefully at least partially answered your question. I want to give a second part, a tiny addition to that, if I may, because there was one button I basically didn't even talk about. I brushed over a little bit, which is called replay. And this actually encompasses a whole set of functionality that is about recording of the decisions made by all the different AI agents. So as the AI figures out how to do a thing, as it gets feedback from you and adjusts and improves, it records everything and it records it as a script. And while you could think about exporting such a script so you have it available for traditional test automation, we actually discourage that. We even just call it a cache. Because what we're saying here is that if you run the same kind of check again on the same software, we will just run from that cache, meaning we don't need the AI reasoning step by step anymore, and it runs as fast as traditional automation. Until, of course, something breaks, which is kind of my point from before. But when it breaks, now we know about it. The agents kick in again. Reasoning is activated automatically to start executing what we want to do here from the failed step on, to then verify if there's an actual bug that prevented that, or if it was just flaky, or there was simply some minor change in the interface that makes the recording break, but we can completely continue on and fix our script along the way as well. So that optimizes that cost and speed, and I hope I answered that question.
Absolutely. So essentially, I'm building automation as I run agentic QA for the first time. So it helped me speed up even writing the automation code if I wanted to integrate it with my system. Okay, so next scenario, we have instead a modern team, right? So using GitHub Copilot to playwright scripts. I could use Cloud to investigate failed logs or debug, and also to write automation, right? So this setup with different pieces of stack of software, it works well. It delivers good to great results. However, my engineer is still managing and locally orchestrating all the agents and maintaining all the tests themselves. But thanks to this workflow, my management and my QA team believes that we have now achieved AI nativeness. So we are pretty good. How does Agentic QA compare to the rest of the tools on the market, and why would I need to switch?
Yeah, great question. And let me start by saying there's a 0% chance of me answering this and not sounding a little bit defensive. So bear with me. I will do my best. Using Copilot, Claude, connecting them to MCP servers like Playwright and others to accomplish automation, to accomplish even performing tests, potentially even fetching and pulling data into different systems in-house. Those are all amazing things. And if the people on your project or in your company are doing them, that's really good. That's great, because we need that form of adoption. We need people to actually experiment and find those kind of solutions. In fact, it is quite exactly what we have done and what our solution Agentic QA is based on. So doing that and figuring, man, if it would be possible to put this out to everyone, have it adopted, build on top of it actually to make it also robust, reproducible, have KPIs about how well it performs, how much money it might save, how fast it is. Have things like check suites shared with others and the agents that improve them. That would be great. Basically productizing these kind of demos, I would almost call them, those island solutions that individual contributors build and make them very, very powerful. And there are amazing blog posts that can be written about it and videos created, but turn that into something that can transform your company. I struggled for an analogy a little bit, and maybe it's not a perfect one, but it's kind of like the difference between someone learning woodworking as a hobby, getting really good at it, creating beautiful furniture, amazing results, something you couldn't have done before because of the right tools. But that is not comparable, and you shouldn't mix it up with, well, building a house, or better yet, building a city. Right? Because that's really what we're talking about, productizing these kind of processes and everything around them, putting them on-prem, making them available to everyone, a nexus of learning also about testing activity, is really getting close to a dark factory. This is something that has the power of transforming whole departments and whole companies. And when I'm talking about transformation, the way that we and EPAM usually looks at it is through the lens of an AI maturity scale. Right? It starts at, starting to employ some AI assistants, building more and more autonomy, eventually having truly autonomous systems, and at the end of it, humans merely assisting autonomous systems like dark factories in accomplishing their key job. I'm simplifying here, but on this kind of scale, to move your department, your project, your company up the scale, become more future-proof and more and better at actually employing these solutions, at adoption inside and outside the company of them. That is the goal of these kind of true productized agentic systems. And it doesn't, in any way downplay the value and the amazing results you can get from just connecting Copilot to different MCPs and doing stuff. But I would venture this is a different category. It is a different category of problems to solve. And I think it would be really important to think bigger than having these island solutions. Yeah, I think I will leave it at that.
So in essence, consolidating all of this fragmented stack in one solution and even more. So
even more, indeed.
Understood. Okay, thank you. So my next scenario is I have a team that already passed the initial AI curiosity. So my team have tried numerous tools on the market and spent a lot of time onboarding, figuring out how they worked, only to get great to mediocre results and constantly have to fix on the generated output, updating it. Because of this history, my team is skeptical of this AI native overpromises, and now worried that generated AI agent or solution are untrustworthy and providing untrustworthy results. So also we are not sure how these new solutions are fitting into our current DevOps pipeline. So as a result, we prefer to stick to what we know, to manual testing and automation. So how this all sounds great, right? Like the solution sounds great, moving into agentic mindset sounds great, but how do I convince my team, my manager, that agentic systems are the right solution after all the failed attempts? And how does it fit into the development lifecycle?
Understood. Yeah, thank you. This is, to a degree, a tricky one. Because one answer would be send them to talks like this. It's tricky because you kind of have to consider they might have been using it wrong. Right? They might have, to a degree, considered those solutions that they employed as traditional software, thinking in very deterministic ways, thinking in KPIs in terms of speed of execution, for example, and deterministic execution versus actually the overall return of investment when you think about maintenance cost as well. So this is certainly a factor in here. But that being said, you can't actually counter skepticism every time just with facts and with dry kind of information. I'm saying that in any group, in any company, there will be both passive and active skeptics, right? And they will all have justification. They will have had certain experiences, opinions that are based in some facts, but also some feelings. None of this really matters, first of all, the reasoning for it, because at the end of the day, what matters is that the outcome is a fear of these kind of changes and the fear of what they can do to their job, to the company, to the market, to society even at all. So the only way to really address this is by working with someone who knows how to address this. Right? This is why EPAM very much focuses on not selling software, but services. We have done these kind of transformations so many times. We know how to address these kind of concerns. We know that oftentimes the concerns originate not even from the feature set of the software, from what AI does in particular, but skepticism about how it fits in. As you mentioned, how does it fit into that DevOps pipeline? Frankly, there are other examples of how does it even work if we don't have good specs, if we don't have a stable staging system. What can such a solution do? And the answer is you're absolutely right. This is exactly what needs to be addressed together with employing such solutions. But having these kind of issues and having negative experiences with other solutions should never be a good enough reason to not try again and do what the future holds for us. I will say one thing, and it's a little bit provocative that maybe, but I will leave you with that question. Think about what happens if you don't. If you don't manage to convince, if you don't actually are here in 2 or 3 years from now, how will the competitive landscape look if the skeptics win in this instance? So you need a strong partner. EPAM is such a strong partner. That is the short version of the answer.
Let not miss that train, and let not
Don't
the fear rules overrule.
Very true.
Okay.
Now,
thank you.
Thank you very much. Now, having said all that, and having looked at in what kind of ways that mindset change and how you act with software in order to get more value out of it matters, let me actually show you an example of how far you can take this. I will show you something that we have done with Agentic QA rather recently, with a minimum amount of work, in fact, a couple of afternoons maybe. The reason here is the mindset and the approach on how to assume how far you can take your AI agents if you figure out how to talk to them right, and how to minimize the actual effort you have to put in changing anything systemic, but rather adding skills, explanations, and the right sources of data and tools is tremendous. And To give you an example of how you can take it, you have seen Agentic QA test on a website. I talked to you about it, working and testing on real devices. But with some effort, you can take it further and in fact ask it, not even in proper English, to play Minecraft and build a shelter. You can ask it to figure out its surroundings, to start building walls, which it just does based on the simple instructions, make mistakes. You can see here it only placed some of the blocks because it was standing in the way, but it figures it out. It figures out it needs to move out of the construction area. And after that, it can complete that north wall. All the way to actually building an entire shelter with a bed, with even torches, because it's for survival, important. All of this ultimately based on a single one-line instruction with a complete documentation of every step that was taken along the way with coordinates and so on. I'm not saying it can now test any game and it's game testing enabled. But once again, if you approach it with that mindset of, let me understand how it works enough so I can give feedback, give training, give access, give tooling, add skills and capabilities, you can really push those systems to enormous lengths that you wouldn't have expected to see at the beginning. So with that, I want to close the talk. I hope this was informative and a little bit maybe even inspiring. I hope that you really think about that aspect of treating agentic software in a different way from traditional software. And ultimately, I hope that you think about all of that in the context of what can be done for your company, for your product or your project. Since Francesca and I would be happy to talk to you, happy to take you into the depths of what else is possible that we didn't have the time to even show you here. And I thank you for your attention, and I'm waiting for the AI questions. Curious to see those.
Excited.
Wow, that was really cool and interesting. Our audience has a few questions on the platform. Let's discuss them. First question, what technical challenges have you encountered when implementing fully autonomous AI testers? And how did you address issues such as test coverage or error handling?
That's a big one. There could be a very long answer. I will just give a couple of examples. There are challenges, of course, with things that seem to be simple. When you know and think about Playwright, it seems to solve a lot of things. But then you encounter iframes and coordinate transformation inside iframes. That is very challenging. You encounter shadow DOMs on websites that make it very difficult. You encounter the challenge of actually preparing devices in device farms with new builds and have them signed correctly. So a lot of the challenges are actually not about what the agents themselves do, although we can go into that too, but the surrounding environment. Test data and specs being written in a way that even a human would understand them, for example. Those are just a few examples that needed solutions nonetheless. It doesn't matter that it is not the AI's or AI agents' fault of not having the right information. It does not matter at all if it is a technical limitation of some tooling. So we had to go into the architecture and the orchestration of those agents with such limitations in mind to make it autocorrect for them, to find alternatives, to switch back to a visual coordinate-based, for example, action if a Playwright action fails because of some limitation in there, which led to this entire tooling service that you saw a glimpse of that allows customization, overriding, and extension of tools that are made available. Yeah, there's a lot more, of course, that we have learned over the time that also sets it apart quite a bit from any of the experiments you might have seen or done yourself with a local cloud instance. But at least I gave maybe a glimpse into that, not to take too much time, unless Francesca wants to add
And
anything.
perhaps maybe we can add, Jan, about the test coverage, right? So we do have an interesting feature as well in Agentic QA that allows us to essentially scout through the site up to 10 pages, but can be edited. And so you provide a URL of your platform, of your application, and what Agentic QA will do would actually go around and scout through the site and record the action as if it was a user. And in that case, it covers most of the path that user would take, even considering some edge cases. So if you have some pages that you haven't scripted yet, you haven't generated test cases for, then you can just feed it into Agentic QA and it will generate test cases for you so that you can easily increase your test coverage.
Indeed. And if you go beyond that, we haven't looked at reporting here. We haven't looked at integrations with other solutions, even from EPAM in terms of report portal. There are other talks about this, in fact, and how you can unify the kind of reporting and coverage KPIs, for example, that includes what Agentic QA does and maybe what your unit tests and other manual testers contribute as well. Yeah, it's a big topic.
Maybe a quick one just to be for completeness, right, about error handling, right? So we haven't seen a failed test or a block test, but essentially we will have an agent that reviews the performance of the session. And if there is something slightly odd and is not able to determine whether the test is passed or it needs the intervention of a human, then it will block the test and provide the reasoning for it so that you can verify whether it's instead a complete issue, like a obvious issue. Then it will create a bug and integrates with your backtracking system. So it creates not only a report that you can see within your test session and within the report page, but you can also basically receive all this information wherever you're tracking them. So that's how it does error handling, if that's what matters. Okay, so next.
I agree with you. Thanks for your answer. And the next question. In your experience, how does the presence of agentic AI testers influence the skill development and roles of human QA professionals within the team?
Potential skepticism that you might find in quite a few teams. I personally decided to employ a very optimistic and positive view on this, assuming that, yes, the job descriptions will change, and they will change in some parts drastically. But to a large extent, they become more powerful. And if a role was a singular contributor in the past, using these agentic systems and how to work with them, like with colleagues, suddenly makes you a lot more powerful and efficient and effective, in fact, for the entire company. Now, there will be also certain kind of activities and roles that might get eliminated. But if you look at the history of industrialization, automation, the internet, all of them, we just never ran into the situation where we suddenly had no job left to be done by people. What we ran into was more exciting, more sophisticated, more challenging new tasks were suddenly on the table. And we retrospectively didn't waste as much time anymore on activities that really don't have to be done by humans, which is something you observe today in many factories and in other kind of settings. So I decided to employ a very positive outlook on it. I fully acknowledge, however, that especially when you look on a society level, this can have an effect, and especially short term, it might not just have a positive effect. It is something to be very aware of, and that I'm happy that at least some countries in the world are also thinking actively about regulating to some degree, sometimes over-regulating, but at least not waiting until some disaster happens. It is a challenge for the entire society, however, not a technological one, I would say.
Well, what I can...
Oh, excellent. And the last question. What approaches have proven most effective for fostering collaboration and communication between human QA professionals and agentic AI testers, ensuring that both contribute optimally to quality assurance?
Another complex one, because it really depends a lot on the kind of company and project and team one works in. There are companies and teams that have kind of a very deeply ingrained skepticism of not even just agentic or AI solutions, but even technological solutions as a whole. That's a different set of challenges. The most important part is highlighting the individual contributors' benefits from engaging with these platforms. It is the age-old question, what's in it for me, that needs to be answered. If you find the right answer to that, if you find the right answer in the context of their career, of their position, of the company they're working in, then usually you are creating the necessary motivation of those people trying to figure it out on their own. It is not about a dry lecture and a handbook about how to use a system. It is all about figuring out how to find the right motivation. And that is the short answer to what works best. Not necessarily the easiest thing to do, but certainly what works best.
Yeah, as a QA engineer, what motivates me in this case is to upskill and to continue following the trends of technology and evolving technology, and in general to make my life easier and not replace me necessarily, because we don't want to remove the human in the loop in this case, but just simply share different tasks than we used to before. So.
Guys, thank you so much for your inspiring and very useful presentation. For your clear, informative answers, it was great to hear your practical advice. You truly energize and motivate us to move forward. Thank you for sharing your experience and supporting our professional community. See you at the next events. Subscribe to our social networks. We've got tons of cool content. And don't miss our awesome challenge on social. Check out our pages for all the details and jump in on the fun. And now, let's welcome the next speakers.
Thank you, everyone.
Thank you very much.
Please wait a little. We'll get back to you in a moment. Please wait a little. We'll get back to you in a moment.
everyone! We're having a fantastic competition for all attendees featuring great prizes for those who complete the contest terms. The only condition is to tag us and submit on any social platform and then win a prize. More tags, more chances. Good luck. Our next speaker is a sociologist, methodologist, and independent researcher who currently works as a quality assurance engineer. His passion is learning and applying knowledge in real, educational, and business projects. In recent years, he has successfully combined social media analytics and data science, using programming and methodology to analyze big data and create meaningful content. Meet Carlos Andrés Muñoz Sandoval.
Right. Hello, everyone. Good morning, afternoon, evening. Thank you so much for having me. I'm Carlos, usually called Charlie since I remember. So just say, I'm Charlie. I work across tester initial levels from onboarding green coins, new testers on the platform, social media, marketing, community building at Test.io. Wherever our freelance testers and our platform meet, that's usually where you'll find me. So let's start with the following. A crowd tester pool isn't built on one platform. We are talking about social media, so platform on social media platform. It's stitched together across paid acquisition, community spaces, and ongoing engagement. And most teams treat these as separate problems when really they are one system. Here's a way to think about today's topic. If you're coming at this from QA rather than marketing, for instance, you wouldn't run one test case against every browser or every device, every user type, and call that full coverage. Each environment is checking for something different. Building a testing community works the same way. Run the same content against every channel, and you don't get full coverage. You get one channel doing all the work, while four others sit and test it. 5 channels, 5 different jobs. Same idea as 5 different test environments, just for people instead of browsers. Or you cannot tell the same job to different people expecting getting the same result. Sometimes you won't get anything, not even a laugh, for instance. So let's start with who we are. Let's start with the agenda first, so we know where we stand. Who we are. Social media planning is the second point. Discourse as engagement hub. A little bit about paid recruitment. Community representatives, very key when you are growing a community in places where you are very new. Milestone standouts and takeaways. So who we are. We are, before we get into tactics, the quick snapshot of who we actually are is we are a diverse network of dedicated testing experts and freelance crowd testers from all over the world, from all backgrounds, cultural speaking, social speaking, and as most of our tester universe from different professional backgrounds. Our mission, this will be more important in the context of building a community on social media. Our mission is empowering crowd testers worldwide to bring their unique experience and skills to customer products. Our vision is uniting testers globally to these important pillars: earn, learn, and grow. Through flexible work inside a safe, inclusive, and supporting community. And this translates into our values. So we have 6 values that sit behind everything you'll hear today. Collaborate effectively, strive for excellence, act with integrity, engage proactively, respect everyone equally, and widen horizons. These are a poster on a wall, to decorate your room or the office. They are the filter behind every choice uh, uh, on social media and in this talk. We are active across 5 channels, and each one has a generally different job. And more on that shortly. 3 things we've been focused on lately is first local community building, and this is meeting testers' demand in a specific markets and customers' demands on a specific markets, and supporting testing activity there, including in-field testing. Concrete, there is also one of our 2 cases. This is kind of a new profile structure, localized content. 2 cases here is our newly presence in Korea, South Korea, and Japan. The second part is AI popularization among testers. We help testers get real value from the AI tools now built into the platform, our platform, through different ways, loops, dedicated Discord space, and related content. And finally, social media and Discord development, the core growth and engagement work, and which is most of what the rest of this talk is about. Day to day, the team focuses on 6 things, mainly supporting delivery, running the testing activities clients actually need, the projects they are working on, freelance, and we are collaborating with freelance tester engagement, tester retention, supporting educational activities, working with community representatives for local development, and collaborating with other testing communities and even institutions. Let's move into the system, because content here has to serve on our platform to serve 2 different audiences that often get treated as one. And the organic community, those people already testing with us, engaged, looking for belonging, and the recruitment funnel. And this funnel is people who don't know we exist yet, even those who are going to some LLMs asking for working as a tester, or side hustles, and they found us there. We are very well positioned there. So for those people, we also talk to those. And our content calendar keeps this separate on purpose. We have organic content that builds trust and visibility over time. It was the purpose of, from the first couple of years of our socials, were focused on create this trust and our online image. And the recruitment content, organic content, is that when there is no paid, and the recruitment content that is performance driven and channel specific, which is basically true advertising. Everything we publish across every channel maps back on. That's why we are. That's what you are seeing. That there is like a formula: acquisition, community, engagement. Those aren't separate problems. They are just one system for us. And that's why these 3 within the system are key: the acquisition, the content part, how we plan it, and how we work on Discord. More shortly on why Discord is so important here, and our representative and our pillars. These pillars are crucial because everything I was saying, everything we publish across every channel maps back to this, and earn, learn, and grow. And that's just not a tagline. Is the filter every piece of content runs through before it goes out. A post about, for instance, a post about a testing opportunity is earned. A bug breakdown tutorial is learned. A career journey story is grow. The strongest content usually touches more than one pillar at once, and none of this gets decided platform by platform in isolation. And that's where we started with the beginning. Is like these are different separate platforms. We run everything through a shared planning board where the team maps out themes, series, contributors together before anything gets scheduled. And this is because it's important to understand this part, is because the community content, bug content, recruitment content, a new project content often come from different people, and without one shared view, channels drift out of sync with each other and won't get any result, and at least very far from the ideal for what is expected. So each platform is our ecosystem. In our ecosystem has an assigned strategic role, and that role changes what the content is actually for. No, not just how it's formatted, which is some of it was one in the beginning when social media started and brands started to have presence on social media. That's how it was kind of conceived. In our case, Facebook connects people to the community emotionally. For us, YouTube teaches, so we have long form educational content there. Instagram helps people discover visually. Our platform, LinkedIn, supports professional growth. Discord is our life hub, where we have real time, peer to peer, and is not broadcast at all. So the same, for instance, the same story, say a tester career journey, gets told five different ways, but not because we are bored, but because the job each channel is doing for us, and for most teams should consider this, is different every time. So while connect is grow, discovery is learned. Oh, sorry, I changed in a bit. Discover is learned. Publish the same post everywhere, and you're not being efficient. You are wasting you are wasting 4 of 5 channels, and that's quite a lot, especially when everything is driven organically. So here's 12 straight. Here is 12 straight month of that differentiation I'm describing through the year in practice. Through the last year, YouTube and Facebook climbing every month, no plateau at all on either line. This started at very different sizes and stayed at very different sizes. That's not the story here, but the story is that both kept growing steadily for a full year while getting generally different content treatment the whole time. 2 channels, 2 very different starting points, 2 very different goals for us, 2 very different audiences, and both still climbing a year later. That's not luck. That's definitely that's the outcome of a year of treating each platform as its own job. This is another case where LinkedIn and Instagram are growing, different sizes, everything different, but keep growing with this idea of differentiating our content. What happened in October last year, around October, November, and is helping this. You can see that it's kind of started to grow a little faster than the other month, and it's because we run a large-scale tester feedback survey, several hundred responses, around 700, and what we wanted to find out where social engagement was actually working and where it wasn't. And the headline finding is certain platforms, particularly Instagram and Facebook, show real engagement gaps relative to where our testers actually spend their time. And that reshape where we put our planning efforts. Effort is not enough to post content and hope it converts. We built a framework to trace social activity back to actual tester acquisition and engagement and retention. Instead of, for instance, instead of relying on platform native vanity metrics like likes and shares and those standard ones, if we cannot trace a post to a sign up or to get testers on a test cycle, we are just decorating or just not recruiting. We have an interesting experiment where we share content on different platforms and evaluate whether the one with more information about a test was on social media was better than, for instance, an email platform message. And we found out that the one on social media was more successful. We put new testers there, very narrow, for a very specific location. And these testers not only join, but also work very actively on this test. So that was one interesting finding of this experiment. As for Discord, Discord, as mentioned before, is our engagement hub. Planning gets people's attention, so Discord is where they actually stay. It works fundamentally differently from a broadcast channel. It's not a place to post an announcement and walk away. Like, let's see, and next day, let's see what happens. What community happens in real time, peer to peer. And our clearest example is structure competition for newbies just ended last Saturday. We use a point-based scoring system, so new testers always have a clear sense of progress. We built a consistent set of messages, templates for judges and competitors, so the tone and quality of interactions stays high even as different people run different rounds. And running is a recurrent structured program, not one-off, and that's only possible within the scope. Is what keeps the server active instead of dormant, like it might happen on some, for instance, Facebook groups. Community management isn't a one-time setup. On this platform is an operating rhythm, pair-driven engagement. Because when I mentioned that is because testers recognizing other testers, judges giving feedback, and judges are team leaders on their test cycles. They join, and these team leaders were also testers on our platform, me included. So skills far better than relying on staff to manually drive every conversation, for instance. Beyond the headline competition, there is a steady rotation of smaller formats that keep the server breathing in between the bigger initiative. All right, just checking my slides. For instance, fun activities that need no production at all, trivia style quizzes, polls for community input, and we get those results and we use it to create content to help testers or to guide testers based on the results. Smaller testing competitions outside the main tournaments, they are more frequent, but lower stakes. Yeah. None of these need a content calendar slot, but we do have it because we run many of these and our server is huge. You don't need a designer, but we do have one for sure, luckily, and you don't need a budget line. They need what these activities need is someone willing to open this call and ask a question. That's it. Most teams watching today don't have a dedicated social budget, but everyone watching has the ability, or anyone at all, the ability to open a server and ask a question. A Facebook page is generally easier to keep alive and maintain than a Discord server with a few thousand members, but the bar for participation is passive. The difference, you just scroll, while Discord definitely asks more of you operationally. Someone has to show up and prompt it, but it pays back in actual relationships, not just impressions. And that's what creates community. If budget is your constraint, for instance, this is where to put your efforts first. Some words on paid recruitment. And this is more like context for us. This is not the centerpiece, since most teams here maybe won't have a dedicated budget for this. But we do have run campaigns across Meta and Google Ads, mainly because Meta gives just an idea of why those two, but Meta gives broad reach and a strong retargeting. Also faster results, like less time, while Google Ads capture high intent. People already searching for a testing or freelance work opportunity, or because we need their browsing behavior for a project or test. So in these cases, that's how we use a paid promotion. But there are cases where we are new, like Japan and Korea, in South Korea. So we need to understand these audiences, because it's different from this side of the world. An example of how we filter the content and how we adjust to this new audience. Well, we have for one very large project in Japan, we have this landing page, and commonly on this side of the world, the best practice is if you have a landing page and you have a form and you want there to get some leads, people to put the email information, you put it at the top because you don't want them to waste time scrolling. However, after understanding the Japan audience, we restructure completely this landing page and actually put this form almost at the bottom, because for that audience, for this project, on that context, building trust was more important than just they won't just give away your email and information and close and keep navigating somewhere else. It's very different. So these kind of things we also have to consider when working with paid recruitment. Also, as mentioned at the bottom of the slide, we even built a simple an internal cost per lead benchmarking tool We have three different levels: optimistic, realistic, and conservative tiers. So we paid spend gets judged against a baseline instead of guessing or comparing to benchmarking, very well positioned benchmarking, but they don't work, they don't fit all projects or initiatives. So one concrete result from that tool and the work is like a recruitment push for a very niche testing landed on 50% plus reduction in cost per lead against this baseline, these benchmarks. I mentioned, and keep that number in mind because it comes back later. A large enterprise recruitment campaign also taught us the value of simple status reporting, status blockers decisions, even at a scale. For let's community representative, let's talk about them. And so while paid channels in Discord get people in the door, community, especially for these new markets, community representatives are the connective tissue between platform level strategies and individual tester relationships. So they surface ground level sentiment and friction points that it's possible that to show up, or they never show up in a dashboard. In return, they need clear context, our representatives from us, about what's coming, campaigns, competitions, policy changes, so they are never caught off guard in a conversation with a tester. Community representative are your early warning system and your trust ambassadors at the same time. Is a very symbiotic relationship that is always rewarding. Treat that relationship as two-way, not top-down. We now cover the how, planning, the scope, paid channels, and the human ledger that holds it together. But let's close by looking at what that actually produce our case. So some milestones and standouts. So this is the receipt of everything we just covered. Over the last 12 months, YouTube up 81%, from 16,000 to over 3,000 subscribers. Facebook up 37%. Remember that this is 95% mainly organic. We are not paying for this. So from around 5,000 to over 6,000 followers. LinkedIn, the same. This one is up 65%, from 600 to over 1,000 followers. And our new baby, Instagram, from 200, it was up to 266%. And I mean, from 100 to over 400 followers. So that's big. Every channel grew this year, but not at the same speed. We don't expect that. We are not expecting that, and that's actually the point of this whole talk. The two channels we put the most platform-specific effort into, YouTube and Instagram, are also the two that grew fastest. That's not a coincidence. Again, we're claiming after the fact is the trend we set out to create. And Instagram had the most room to move. Evidently, is the new born, and it moved the most. YouTube, on the other hand, at roughly 30,500 subscribers in a single year, when we were only getting views in the past. So the heaviest lift in absolute terms for YouTube, and LinkedIn is going that is that way, and that's what we want. Two more highlights worth callback. On on the local side, the location for on the side of locations, on the local side, we got new representatives on these very challenging markets, South Korea, for instance, Japan, more subscribers and followers across the markets we've been investing in, and we investing organically in. On the paid side, we get testers landing for niche testing, 50% plus reduction or in cost per lead from thanks to our benchmarking tool. We could address that, and now we documented and compare. And the same number from I mentioned earlier is coming now as a proof. None of this was one big win. Is the planning, the discovery theme I mentioned earlier, the paid mix, and the people all compounding together over a year of work. So what can you take from this and use your maybe what let's get to what you can take from this and probably use Monday morning already. First, in our case, 5 things to take with you regardless of your team size or the budget. Or one is separate your acquisition channels from your retention channels in how you plan content and measure success. They have very different jobs, so treat them independently and work them independently. Second, don't trust platform native metrics alone. I mentioned likes and shares; those are with standard social media metrics, but they might not work for you. So build even a simple attribution habit. You know what actually is working for you and for your audience and for your specific platform. Third, treat structured community programs like the competitions I mentioned as engagement infrastructure, no one-off events. The recurring rhythm is what keeps a community alive. And that's why we can see every week, every time we need testers, we go to this core and we have a new opportunity, a new activity there. They are there because we are engaging all with them. And you don't need budget, you just need someone to ask. Fourth, build as more if possible, build more internal tools to benchmark and estimate. For instance, in our case, cost per lead, but you can also use it for engagement rates, for your kind of rates, for the ones you are interested in, rather than guessing. You don't need a big analytics stack to make better decisions. You just need some system. You can track it down, you can understand it, and you can share, you can read it to understand the findings, what they are telling you. And lastly, invest in the human layer, community representative, judges coming from testing for the competitions, moderators. That's because channels bring people in, but people keep people there. And so that's everything. Thank you so much for your time today. Happy to be here.
Wow, superb, cool, very helpful. And we have a few questions. Let's discuss them. So Carlos, how do you ensure seamless integration and communication between testers recruited from various channels, especially when leveraging platforms like Discord alongside traditional social media?
That's definitely a good one. This is because, as I mentioned, our pillars and our values, and we use them to filter all the content. What we put in images, the captions, the hashtags we use, and that's when people goes to Instagram and goes to Facebook or LinkedIn, they will know we are the ones who are talking to them. And that's because the communication is built on this. In my introduction, I mentioned mission, vision, values, and because we have this structure, this concept, like conceptually, we know who we are. We can tell and we can talk to others on what we do and how we can collaborate together. So I think that those are our pillars are key, because learn, earn, and grow. Who doesn't want to grow while learning and putting some money in their pockets? Most, since we are working with freelancers, that's very important. That stands out to any freelancer out there. And if you are one, please join Tesla community. And that's how we ensure that seamless integration in communication.
Very interesting. Next question. Can you share examples of automation or AI-driven solutions that help manage and scale community interactions or moderation tasks?
Examples. We have many examples, like how we can effectively and efficiently filter our communication with this this concept of who we are. We have built some projects, and with LLMs are reshaping our content. Of course, we know what is important for our testers. We all came from test. The entire social media team is still testing or came from testing. So can we ensure that we don't miss anything? We have our LLMs and our robots and our ways to shape with these 6 values and with these pillars our communication, so it can go smoothly. It creates it has the same balance, all of them, that's important for the communication, and that matches the purpose of our platforms. Remember that we don't a communication for learning, even if they might touch different pillars, a communication we want to be focus on learning, won't touch grow, for instance. And that's how we guarantee that does not happen, that message will be delivered effectively is through our AI driven solutions. And we have many of those, from reviewing captions, reviewing designs, analytics. We have all of those tailored to this concept we are built on, which is who we are and how I started today. Good question. Thanks.
Oh, really? Cool. Thanks so much for your answer. And the last question, what strategies have you found most effective for fostering engagement and knowledge sharing within a diverse tester community? And how do you address challenges related to maintaining motivation and participation over time?
Since this from the last year, and most of what we have identified that is working for engagement and knowledge sharing is, after this survey we ran with over 700 responses around that number. And it was how we can, the only way we understood this, because we tried many things, many formats, different approaches, evidently on different platforms, is that we needed to touch a little bit, change a little bit the way we deliver content for our testers from how a tester could experience it firsthand. Before we understood their problems, we understood what could help them to grow, to learn, to start working on this and that kind of type of testing on our platform. And then we started to go over all the feelings around testing, the motivations around joining our platforms, and what they can share. We understand that on this call there are some testers are coming, commenting and trying to help others. So we merged all of this and make it interactive on our mainly on our community tab on YouTube, Tesayo community YouTube channel, where we can see how we can teach them about the same topic while we are getting their input on what we are teaching them about. And then they can also see other testers interacting, and then they are commenting on them. So as we can ask them, basically the headline is asking them about themselves on testing. I mean, on their testing, the testing work on the platform within a specific scenario, within a specific topic. We tried that different ways, different times, and different platforms. Now is working beautifully, and that's also because as a crowd testing platform and our growing socials, we get new waves of audiences every once in a while. So while and this is quite key, why it's working now might not work next month or next year. So that's also part of analyzing your audiences, your content, and how to keep creating pieces of content. It can be just only text that could foster engagement and this knowledge sharing. And knowledge sharing is mainly, and we can see it every single day, every single minute we open Discord, any channel, it will be on Discord. Because that's why it's our live hub, because everything is happening there. If we put people together to talk about the same interests, they will definitely talk and collaborate and engage and give back, for instance. So yeah, I think that's the answer for this. Thank you so much. Another good one.
Excellent. Thank you. Folks, if your questions aren't answered, don't worry. Our speaker will respond to everyone in writing as soon as possible.
Wonderful, Carlos. Thank you for your thoughtful responses and engaging talk. Your experience and enthusiasm for building professional communities through social media really resonated with everyone. We appreciate your contribution and the inspiration you brought to the discussion, especially your practical insights on uniting testers and sharing knowledge through different online platforms. Remember, our amazing contest is in full swing, and you can still score awesome prizes by completing the contest rules. Follow us on social media to learn more and join the fun.
Please wait a little. We'll get back to you in a moment. Please wait a little. We'll get back to you in a moment. Please wait a little. We'll get back to you in a moment. Please wait a little. We'll get back to you in a moment. So, ladies and gentlemen, we're having a fantastic competition for all attendees, featuring great prizes for those who complete the contest terms. The only condition is to tag us and submit on any social platform, and then win a prize. More tags, more chances. Good luck. Let's welcome our honorary speaker, an experienced program QA manager with over 20 years in IT and head of quality engineering practice in Canada. She successfully manages large and diverse projects, builds effective QA teams, and implements modern approaches to automation and performance. She also combines strategic thinking with deep knowledge in banking, gaming, and retail, and her leadership and communication skills help her achieve outstanding results in complex and dynamic projects. Meet Natalia Moisenko,
and co-host is an expert with over 10 years of experience in software testing. He has led and mentored QA teams, successfully built testing processes from scratch, conducted quality audits, and implemented improvement. He has delivered projects in e-commerce, mobile applications, insurance, and retail. He holds ISTQB Agile Safe and AZ900 Microsoft certifications and has completed quality architect training at EPM School. Meet Daria Poluektova. Girl moves on.
Hello, everyone. Hi, Daria. Hi.
Yeah.
Hi, everyone. You can hear me, right? Dasha, can you please confirm?
Yes, we can hear.
Yeah, so guys, really happy to be on the stage today. Really happy to share the stage with Dasha today. And what we will be talking and presenting to you today is actually about our experience on the Canadian market, because we both, myself and Dasha, working for many years for one of the biggest Canadian company, and we will be happy to share what we have achieved, what we have done, and how the big enterprise operates, how it differentiates from the other maybe smaller companies. What does it mean to be within the enterprise, big enterprise organization, and what actually didn't work as well. This also our experience, which we will be happy to share with you. So Dasha, if you don't mind, if you can share the presentation so we can start.
Sorry, I'm trying to share.
Yeah, that's
One
okay.
second. Okay, can you see it?
Yes, I can see. I can see. This is me. I somewhere I can. I have my glasses, so just like another another hair color, but it's still me. And a few words about myself. My name is Natalia. I'm located in Toronto, Canada. I'm currently a Center of Excellence for Quality Engineering lead and driving the quality transformation for not only for EPAM Canada, but also for our lovely customers and for our clients and for our colleagues. Actually, for the last 10 years, I've been working for the Canadian larger retailer, but actually it's a huge company. As I said, it's like a price, and also we have quite a number of people working for this organization, and hopefully we will be staying with them for way more longer. So what we are doing and what I have contributed is to establish the governance on the enterprise level, quality standards, and also how to work comfortably and efficiently in multi-vendor environment, and drive the delivery at scale. Personally, I'm proud of, but I'm 5 times CEO award recipient, and the last CEO award I've got for the AI introduction in our projects. However, Dasha here actually bet me on this, because she's actually 6 times CEO award, and whatever you will hear on this presentation about the AI introduction, it's mostly like the credit goes to Daria, because she did a lot, and I believe she will present and she will share with you what we have built, what we have achieved. But actually it's our shared achievement, and more credit goes to Dasha for sure. So maybe Dasha, you can move to the next page and introduce yourself.
Yeah, thank you, Natasha. So yeah, it's
Dasha
definitely it's our common achievements and common benefits we gain from all of this experience. Let's with Canada largest retailer, it's true. And we had a lot, and we will discover today. Of course, we had the pains and some issues with our adoption, AI adoption, and stuff. So yeah, I also like have this awards from CEO like for different achievements, not only IA transformation, but the latest several, I think, recognition, including for IA adoption and transformation impact on quality delivery and on SDLC in general. And also, I'm currently playing the role of a functional testing competency in the PAM, and I'm like trying to still to be live with functional testing. I know that it's kind of complicated and hard, and artificial intelligence is trying to move us like forward with new challenges and new achievements for functional testing especially. And today I think we'll touch this topic as well. So yeah, we are ready to start.
Yes, absolutely. So just a few words about how this presentation is structured and what we are going to present to you. This actually this presentation is also not only to present what we have at our place, what is our experience, but also how the situation has changed over the past year. Maybe everyone can make a pause and try to reflect where we were a year back or maybe 2 years back, where maybe majority of us were worried about, okay, will AI steal my job? Right? Do we still need keys or maybe some other professionals like IT professionals? What will change? What will happen? Everyone was making some prediction about how the key will transform, how our role will transform. So just like make a pause and think about it, because actually it's a long journey. We live currently in a very interesting time, guys. It's the time which can be compared maybe with the introduction of internet or the cell phones or whatever. We live in a very interesting time, and of course it affects and it will affect all the I mean that maybe everyone, not only the QA professionals, right? So what we will be going through in this presentation, we wanted you to showcase what is actually the key challenges when you go on the enterprise level. It's like why it's different from the other set of organization. As I said, that what worked, and I hope that you will feel maybe that's actually you are not alone in some of the journey or some of the challenges, because the challenges I believe every company or every QA lead faces with quite typical, and we will be happy to share some maybe recommendation based on our experience how to overcome these challenges, how deal with some different types of resistance, how to organize the work, and also what is also very important, which metrics and on what stage about the AI adoption specifically or some other things you can collect, because it will differ from depending on where you are. Also, we will be sharing the framework based on our based on our pain and the history of how we adopted AI on our organization. We will be sharing this framework, how to scale and what will be the stages of this adoption. And also there will be a small maybe talk just to give you a kind of like idea. I know that a lot of our colleagues already talked about the same, about where we are heading. We will also share our perspective where the profession goes. So maybe next slide. Okay, so this is actually the session overview. I've already went through this overview, so setting what is at scale really means, the reflection based on our reflection, but I'm really asking you to do the same on your organization with your team. What is changing, what you need to have in place before you are introducing any AI, whatever AI or whatever agentic flow or whatever you want to bring. You need to have something in place as the basis to make it successful. So what worked, what didn't work, and also Dasha will be sharing with you some practical use cases, and also she will be talking a lot about the agentic flow. Next slide, Dash. Okay, so quality engineering at scale. I will start from this so you can understand better why we feel it's different, why we're really proud of this experience, and why we're really actually happy with Dasha and with all our more than 200 quality engineers working for the same customer, why we're really happy to be a part of this organization. So usually I'm talking about some average setup. Of course, every company is different. But when you have like slightly simpler setup, you have maybe single product or limited scope, maybe you have one delivery team, maybe couple of delivery teams, but just limited number of vendors or maybe one vendor. You have quite a unified tooling framework. You know whom to ask, who is responsible for what. Usually in the like smaller organization, everything looks like kind of like transparent and clear. You also have a luxury of getting the feedback very quickly. You can approach to people. You might not be in need to have like a huge meeting or collecting some metrics. You can just come to one person or to another and ask how it's going, what are the problems. This is actually definitely the advantages to working on the smaller organization. When I say small, it doesn't mean it might not be small, but just like a transparent, and just a bit unified. And Dasha, you can click, and the another yes, another column appears. So now compare when you work on the enterprise level, you might have, or definitely you will have, the portfolio of the different products and domains interconnected. Somehow you see that somehow they might not be connected, but they might be dependent and being affected. Whatever you bring to one project or portfolio, there are a lot of things which can be affected by this. Usually you have the multiple vendors. What multiple vendors in practical sense means? It means that different business culture, different delivery approach, might be even different SDLC. And imagine if you have just like several vendors, and you need to find the common ground, and you need to understand how they operate and how to benefit from this setup. You might have fragmented tools, framework, and standards. It means they are not unified. It's like a huge organization. You don't know who is responsible for distributed ownership. What else? Environments is always a pain, but imagine if you have a really complex architecture, really complex dependencies, how this environment challenges even become even more challenging. Okay. Then also the KPIs reporting becomes way more complex. And what is the most important, maybe cross-team integration dependencies. Just imagine that the environment becomes it becomes more complex and more challenging for you to navigate through all these challenges. Yeah, Dasha, if you can make a click. Yes. So enterprise. What I wanted to say, that enterprise is not a bigger. It's not just a bigger team. It's a way more complex ecosystem usually, with a lot of dependencies, challenges, a lot of stuff like going around you. So, and you can imagine that how poor key can survive in this environment. So this is actually not about the volume, but about the complexity, which it grows like significantly. If you can click next slide, please. And now this was the kind of introduction about the enterprise versus the non-enterprise company. Now about what is actually expected from the QA, not only for enterprise level, but in general. So at one hand, we have a complex, very complicated, a very like challenging enterprise environment. On other hand, we have some industry standards, expectation which actually pushes us even like harder. So we need to deliver faster. Of course, everyone expects that we need to deliver faster, especially with AI. We need to have more automation. We need to reduce costs, right? We need to have not just like metrics, but insights, which can tell executives and leadership about what is going on, not just like publishing the numbers. And in the enterprise area, it's large scale implementation usually. It's like tool capabilities which are evolving really very fast. Then the governance part, then the actually maturity. You can imagine that on one side we've been pushed to deliver faster, to deliver better quality, to move things to the production or to the user, to the end users faster. But on the other side, actually complexity plays, yeah. And also, when you introduce something new, especially on this organization, you might feel even more strong team resistance. This is actually also very natural. It's a human. It's we are all human beings, of course, especially when the environment is so complex. When they introduce something new, AI or quality engineering, which actually evolving from the quality assurance and from the testing discipline to something really what actually matters in the engineering sense, this actually even bring more pressure on us. Dasha, if you can click. I believe I have some summary. Yes, so the expectation is rising. I believe it's clear. We can move to the next slide. So now talking, you see that we have like several pillars. So what I mentioned before, we have a very complex, it's our experience, but if you come to the organization like this, you might experience the same. We have one pillar, enterprise. It's a very complex environment, complex ecosystem. On the other side, we have AI, which pushes us as QA engineers to do a lot of things like faster, better, in the better quality, and also to navigate through all this. But what is actually the basis? You can build your expertise and your delivery better. If you don't have some foundations, you won't be surviving in this environment. So what does this foundation means? That you have some requirements, discipline, because once, and I believe Dasha can tell more about the same, but when you don't have a proper requirements, yes, I know sometimes we think, oh, it's boring, all this documentation stuff is boring, but the requirements, discipline, it's the prerequisite for introducing an AI. Dasha, do you see? Are you actually share the same? Do you share the same idea that requirements are still needed?
Yeah,
Okay.
yeah, definitely. Like we heard, like during our experience and our journey, we heard a lot, like from our QAs, that it's not possible to generate like something with really good quality without any requirements. So if you like garbage in, garbage out, it's like common principle that of course we cannot like violate. So that yeah, you should definitely like work with requirements first to go to AI adoption for QA team.
Okay.
I totally agree.
Perfect. So, Dash, one thing maybe about the requirements I've heard. Maybe you can share your experience. I've heard that for the requirements specifically, there is kind of like direction or some idea that requirements in the agile world we don't need a requirement. But we are on the other side, we are saying that requirements are actually really needed, right? Because we cannot introduce some AI generated test cases or whatever. What do you think? Do you think that at some moment of time we can come to the situation when we can live without requirements?
Like everyone is talking right now regarding this dark factory and that we should go to just idea. Like you are providing idea and business propose, and then it's AI that generate all requirements, so we even don't need to review them. So maybe in the future it will be possible when we have like huge context and backlog, when we have already requirements for our existing application, and then we can reuse it, and we don't need them to formalize these requirements. But like so far, I don't think like everyone is ready for that, and we still like need requirements for teaching like our people and our systems to work with Dark Factory and to work with the world without like any requirements. So maybe in the future, but what we see right now, like to have good and qualified application, we still need requirements and test documentation.
Perfect. Perfect. Yeah, I fully agree with you. And the test design quality will fully depend on the what level of quality of the requirements you have. Also, you need to have the execution control in place, because whatever you you teach your AI, or where you introduce AI, if you have like a messy processes in place, chaotic, not stable, not clear, not being followed, what you are going to actually to accelerate with AI? This will only multiply the chaos you have. This is actually the strong foundation you must have in place before you're introducing some like artificial intelligence to help you to grow further. Um, Maybe that's it from the technical perspective or process perspective thing. But what I want also to mention, before to introduce AI at your organization, if it's like complex or simple, doesn't maybe matter at this stage. You need to have, yes, you need to have some processes in place, you need to have some good foundation. But what you also need, you need to teach your team or to help them to understand what is actually AI, what is the neural links, right? How it works, so they actually better prepared and better understand the technology, because it's not a simple technology, right? We are using it on daily basis, but we also need to understand the logic behind how it operates. And what has actually helped us with Daria when we started, maybe Dasha, you remember that we've started from the bringing some really good experts, like not from the QA field, but from the architecture field, to explain to our key leaders, so they then cascade the message to explain what is actually what is language models, how they work, what is the actually the technology behind, what types of different language models, how those business language models are being trained. I mean, all the technical stuff. It will actually kind of meet two targets. You will bring the proper background or basics for your team, but also because we are all engineers, we are always excited about new technology. It will motivate team. For me personally, I do believe that it's actually kind of the strongest foundation. Yeah, Dasha, do you agree that this training work we did for the team? I believe we've conducted it around, maybe we took kind of like 8 weeks for this training. It helped.
Yes, I fully agree, because I think it was our lessons learned, because we started with like without that at first glance, and of course it was a new field for everyone, like not only our key team but for us with Natasha as well. And we definitely need like background, because we all engineers and we need to understand, like to be involved, we need to understand how it works. And also we need to share experience like from other teams with people who has like hands off this particular work, for example, I don't know, for agent development. So we need to show some practice experience to our team, so that they can be motivated and want to do the same. So I totally
Yeah.
agree. Yeah.
Yeah, and also, guys, if you are acting as the key engineers leads, or like you are in some of the managerial position, this is the human nature from my perspective. People always, people always quite resistant to the new changes, to the changes at all, not only new changes, to the changes. And if you start from the proper training, from proper like educating team or motivating, engaging, and actually help them to be excited about this technology, it will naturally reduce the resistance from my perspective, this kind of like psychological thing behind, it will help you to actually to introduce. So maybe next slide, Dasha. I believe that next slide should be yours, right?
Not yet.
Not yet. Okay. Okay. So this is actually, I will be not maybe stopping much on this slide because it's actually, it explains that from again going back to the complexity of the environments we have. So definitely when you introduce artificial intelligence into your work, yes, it helps you to make the repetitive task like it will help you to do this task, right? It will help you to do faster analysis. It can help you to make some decision. But on the other side, you become like more responsible for the input or for the output of the AI, because you cannot blame AI that the AI did some like wrong decision, right? It means that you're it's your assistant, it's your helper, but you are still even more responsible. You become even more responsible for whatever decisions or whatever information you are getting from AI or whatever decisions you are making based on the AI work. So governance also becomes so critical. And also you see that you still cannot like fully rely on the AI suggestion. And here I would like to say it's my only personal opinion. Maybe it's you can disagree. Sorry, we cannot argue right in this place. But I would like also to say that in order, just like give you maybe a simple example, if I were not having the development background before using the AI for writing for me some scripts or for some code, how would I be able to validate the output of the AI of the code generated by AI? For me, this actually new risk is if you don't have a good like background or good understanding of the actually the subject of your work with AI, you won't be able to validate and to assess whether this suggestion or decision you are making is the proper one. For example, if you are asking artificial intelligence, you are not a doctor, yeah, you are not actually a surgeon. But if you ask to how to make a surgery from AI, it will give you an answer. But will it be a proper answer? Will you be able to make this? Definitely not. Same for the for our profession. If I don't have a basics about the if I don't have a basic programming or technology skills, how I would be able to validate the output? So that's my opinion. I think that yes, it helps, but you need also to learn a lot of things and to educate yourself to be able actually to efficiently use the artificial intelligence. Yeah, Dasha.
Yeah, I agree. And then I
Okay.
want to
Okay.
like, yeah, I definitely agree. And like after that, I want to like to highlight here some use cases. So, and I agree totally that we need to review like result. We cannot rely fully in each of these use case. Like it's just a library and list and ideas like what can be automated with AI, but still like people are on the human review stage. And like also my personal opinion, we are on not on the level when we can bypass all human reviews and just fully rely on the like output and response. So like how we began this journey. So we started with pretty much like obvious use cases for our QAs to introduce with some agents, prompts, like some reusable artifacts. And I will go one by one, but after that, I will like share our lessons learned and our like not a mistakes, but some like lessons that we gain from our adoption on a scale. And I want to highlight that we have like more than 100 keys, and it's hard to prepare and adopt new agents pipelines to such amount of people. And we have like different projects. So no universal use cases. Please do not rely on some universal agents. Provide more practices and more experience to your people so that they can generate all these agents by their own. Like, do not think that we will provide all like as a box, as a black box. No, like we are expecting that people will be involved and people will prepare all these use cases. Yeah, but returning back to that, so first of all, of course, we started with test design. It sounds obvious to generate some agents or pipelines for test cases, for checklists, for user scenarios. And we did it. I think we did it successfully. And like Natasha prepared like huge pipeline with great requirements. So it was developed by her like ideas and steps. Like what we need to start, it's like requirements and understanding what we're expecting from these pipelines and agents. And of course, then we worked with automation part because also like team is close to generation, to script generation, to code generation. So it's also can be covered with agents or pipelines on a scale on the enterprise level because we are reusing framework, we are using like some tools, task management tools, and we can have some like common approaches and common use cases for like all teams, pretty much the same all teams. And of course, it's defect management. So bug report assistant was also generated based on our internal tool. And this agent also can be reused for a lot of teams. Of course, it can be optimized and should be optimized because customized, because we have different like labels and other stuff depends on team. But core logic you can share and prepare as a like enterprise level agent for use cases on quality assurance level. For test reporting and test planning, we also prepared some library of agents for preparing test evidence documents, for preparing test strategy documents based on our templates. And what like Natasha said in the beginning, that we should have governance and we should have like these templates that can be reused and can be reused, of course, by IA agents. And it's a like basic documents and drafts that we can apply to like each team and each squad. And of course, like performance testing, also we have a lot of technical stuff for analyzing logs, for metrics collection, for understanding our NFRs. And here we also prepared like some agents based on different tools like Copilot, where we can then share to rest of the teams and to put in our library. So I promised to share our experience. So what we did, like we started with a simple use cases and asked our team and asked feedback what they want to cover, like what their pains and what their some tasks that they are repeating from like daily work. And the second like, proposal of all this library and agents was like to give experience to our teams as well. So it was not developed by one person. Like my understanding and my idea was like to involve as much motivated people as possible, and they prepared some of agents by their own. And not always all agents like will be effective, and not always all agents will be like reusable, but still people or particular person like gained experience, touched in detail the process of agent development. And in this case, they like will be more prepared for some more complicated task with AI adoption.
Yeah, Dasha, and I do remember that our first attempt to design the agent was really quite bad. Right?
Yes.
Yeah, so we, after that, it's also our experience, and I believe it's expected. We introduced something we thought will be working for the people. Then people were not using it because we've met and we've discussed what we can improve, and we've started from scratch with Dasha. It means that we've created a new algorithm how the new pipeline should look like. We've collected the feedback from the people, and we redesigned agent like completely. And the second attempt was better, right?
Yeah, yeah. The insight of that, start with use cases from the team. Do not start with your own use case that you thought, like as a task manager, will be great for your team. It's not working like that. So team will not be happy to use something. They want to use something that they need. That's why, yeah, like we reworked the approach. We reworked after the feedback. After the feedback loop from like QA leads, reworked this pipeline and starting to ask like what your needs, what your pain points, what we can help you like as well. So yeah, it was I think like huge journey to understand our team and understand needs that for like AI adoption required to be developed. And I will go with then our next step and our like vision for upcoming future. So now we have a library. Now we have experience from our team. Now we have library of like pipelines, agents, and different use cases covered. And as you know, like everyone is talking regarding IA factory, dark factory, orchestration pipelines, and like flows, not only for QA, like for SDLC in general. That's why we are preparing the vision and how we can integrate all our agents in one pipeline and different orchestration flows, and how we can inject human review between these agents. So to minimize the work and minimize the gap, time gap, and like feedback loop between agents, to combine them in agentic flows and to combine them not only with QA, but with automation QAs, with like performance team development, and so on. Currently, we have like draft vision for at least 4 orchestration flows for like manual QA teams. Automation part is already covered, that it's like easier to connect for agentic flow. And what we did, so we have like huge pipeline and huge requirements for our test design workflow, and we are trying to separate it to different atomic agents and then combine in some orchestration agent and orchestration workflow, so that we can minimize the context, like optimize our tokens usage and optimize like time for team to use all these agents, not one by one, but in one combined flow. As you see, currently we have like test design, test execution, and discovery test reporting also like will be developed and prepared like more steps. So currently focusing on test design. And for example, like it's applied for our like enterprise account and projects. For example, for test design, we see like such steps like requirements analysis and code analysis can be done in parallel. And then based on steps and human review to like build these atomic agents like checklist creations and check like existing coverage, then create test cases, and then even check like traceability matrix and coverage. And because of that, we can improve quality of our test documentation and control like each step with quality gates and with like evaluations. So I want to return to the topic what didn't work and what worked. First of all, how we started, like of course we were like pilot, and like we had the pilot agents and pipelines and in general like this adoption. So we thought, like Natasha, I think you will support me, like we thought that IA will help from day 0. So we will introduce the agent, and tomorrow we can minimize test design time to 0. Yeah, and it's it was of course wrong expectations, and do not set these IA targets immediately, and the same for other metrics. So before IA adoption in general will come to your life, we need to understand our metrics, productivity and velocity, team metrics, and what you use right now, in any of the tool like Jira, Azure DevOps, and blah blah blah. Also, what didn't work for us, just from our experience, push the team and expecting that delivery time will not change. So of course, team needs time for learning, for adoption, and we need focus time for that. So expectation was wrong, and I think also one important thing that Natasha already said, that we need knowledge. So without that, we cannot start anything. So we need knowledge for our team, for ourselves, for our managers, and we need to prepare a set of clear trainings and learning paths to recommend our team, and give them time to do that. Natasha, do you remember this time? Can you share?
Oh yeah, I do remember. I also do remember there are a lot of questions, or LLM is just the better Google. It will only search. This is one thing of questions we were getting, which we had to resolve to explain how the LLM works, right? And also there are, it was quite I cannot say it's a pressure, but we've started from setting some expectation about the AI adoption, some KPIs. This is definitely was not maybe, yes, you might need to actually to measure the success, of course, but if you set it from the very beginning, the people might feel even more pressure. They need time. All of us needed time to adopt, to understand, to get deeper into the technology, and only then just don't scare your team with the KPIs from the day one, right?
Yeah, of course. And here, what to do instead. And now we understand that, before, of course, we are on the same level, and we need time. We needed time to be ready for this new understanding and new roadmap, how to do that. So, of course, give our teams to experiment and provide them, as I said, learning paths, tools that we are going to use, people whom they ask how to use, and clear understanding what is our roadmap, and how we are going to use these tools, what can be our simple use cases, and give them time to try around this tool, so they can provide their feedback and gain their own experience on these tools. And of course, focus on some business use cases the team is struggling with. So do not provide some abstract use cases that for them, even not interested to do. And regarding also scope of change and scope of adoption, so we have a lot of teams, more than 50 teams in general on our enterprise account. But start with something small, to prepare some 1-2 pilot teams that can be first group to experience with different tools, different approaches, different use cases, and then you will share more experience and more feedback between each other. What helped us is to have this regular calls, to have IA coaches and IA champions, people who is really motivated, who wants to gain the new experience, new work introduced in their QA teams, and of course to give them understanding that it's not a push, but it's like we are providing opportunity to learn something new, and we are providing some time for them like to learn new market trends. It's not only in our like application and our account they are doing that. It's like global trend, and we also want to be like in market trends and provide them opportunity to learn these new tools and technologies to be like more competitive between each other. And
So
between
Dasha,
these
what I
things.
maybe what I can add to this, and maybe to
Yeah,
all
of course.
our audience, that they actually to introduce any like new technology or new process, it always requires some. It's more about not only learning the technology itself or tool itself, but it's also about change management. And if you are acting as leaders, you need actually the combination of skills. You need to have a good technical expertise. You need to understand, but you also need to pay a significant attention how the change management works, how the people how the you can support your team members to overcome some of the challenges that they may facing with their fear, their like resistance, all these things. It's more about change management from my perspective. Yes, Dasha. And we were like in this journey all together. We also were as leaders. We also were like learning a lot along this journey, because I also had some kind of, and I do believe that Dasha, you maybe share your experience. I also had at the very beginning when we just started this journey, I also had a lot of questions. Why do I need to that design? You don't remember, we had a lot of arguments by ourselves, but it's our nature. You cannot just like skip or ignore it. You need to have some change management process in place as well. This is the plan what we are introducing to you, that give team time, do not push them, give them time to learn, try to motivate, educate them, right? Speak to them, hear their concerns, actually address your own concerns and lead by example. Just don't push. Yeah. It's not
Yeah, I
exactly, we
remember.
are not spacing rockets, we are not like launching the rockets to the space, right? We are not actually, it's like eat elephants, like step by step.
I remember these hard times, I know, a year ago more, like when I gathered my own questions in some Excel spreadsheet and asked AI coaches why it is
Yeah.
not working, why
Yes,
I have
this is
some poor
this is the
quality of
reality.
test cases. Yeah.
This is
So, of
how
course,
every person meets actually the changes in our lives. It's a natural, it's absolutely natural and expected, but you need to have some change management skills at least, how to navigate through the changes. This is for me, it's like very like basic stuff as well.
yeah. And like, of course, like need to start from yourself because you are the same. You will feel the push for a new technologies tools that you need to introduce. Of course, we don't have time to like pause our delivery. Of course, it's not possible. So we are on the same. I think like we are like even more even more. Push right now like from like global trends. I think not only internally, so we need to give our teams like these safe conditions, like safe environment to experiment and yeah, start with yourself, of
Yeah.
course.
Mhm.
Okay.
Maybe we can, yeah, we can move. Okay,
Yeah,
so there
let's
are some recommendations. Maybe Dasha, you can also comment. I think that we are almost run out of time, or Dasha.
and
Or
no,
we
I
can
think we have
continue.
time. Yeah,
Okay,
yeah, we
okay,
have
please.
to
Mhm.
continue. Yeah, we already like shared our experience as a test managers and QA leads. Just to sum up, what should do like manager, not only QA manager. So of course, start with KPIs and find this baseline before AI adoption. and understand, like, for example, if you're introducing use cases for test design, try to understand what's the average time for test design before like introduction, and other like new agents pipelines also should be measured. And of course, you need to understand if it's less time you are spending, more time. So everything can be measured and should be measured. Please do not introduce something to like without any trackers. And convert like adoption into control use. So identify, like, not everything should be automated. It's like wrong from our understanding. Like, it's wrong direction for team to use AI for everything. Now identify like most use cases that can be useful for most of your teams, and then they can one by one like introduce this in real development and real life of QA, and they can introduce them by default in their like testing activities. Of course, highlight risks, because we still have tools like external or internal tools, doesn't matter, that using existing or internal LLMs. And you need to evaluate like which LLM to use, how to use, like which licenses we need for that. So of course we have precondition and risk evaluation for each tool and each use case, and be responsible for that, to highlight it, to try to resolve this all risks before adoption, so the team can work with stable environment and with stable tools or like LLMs for their daily life. And be like on the side of your team, try to understand like what currently they're saying, why they cannot use or can use. And like what our experience, we are starting with pilot group, then pilot group showed like rest of the teams their experience and showed a real positive experience from their testing activities. And only after that, we will find like IA champions and IA practitioners that can be involved deeply in development and adoption for rest of the team. So find your supporters, find team and people who is really motivated with that, and group core of your QA leads or QA like seniors who can help with that. Natasha, what is your like insights from that experience?
This is actually, you've covered pretty much all, I believe. Yes, and maybe we need Dash just to sum up with the phased approach, right? Because we've covered a lot from our experience, from the just maybe guys for you, you Dash, you can cover this. So we just like frame it into the stages of what we did and what we've shared with you.
Just in some timeline for our scale and for our level, it's not a one day to adopt, of course. So for foundation and explore, we like definitely need like at least 1 month or even more to find your metrics, to find your use cases, to prepare like learning paths, to prepare team for like tools, for maybe some certification, depends what you're going to use. So even more, it's not just one-time action. And then, like my opinion, the most important stage is experiment, when not only you as a QA lead, but your team will gain this experience from development and from preparing some agents pipelines. And only after that you can share your lessons learned, your failures, your positive feedback to rest of the team and adopt for scale. And this part is also can take up to 3 months, because we have a lot of teams. It depends on size of your teams, but still after that you can gain more use cases, try to build your library, and reuse and reshare this library for like everyone, maybe not only for QA. And scale and measure step, it's something that long term, do not expect from even third or second month some huge results. you will see only in long term, and you will see some impact for effectiveness and for productivity of QA team. And it's like as the same as agile. It's something that you need to retrospect, to analyze, and to prepare some improvements. It's an ongoing project, and it's not it's unstoppable. So each month we have new market trends. So be prepared for everything.
But there is no way back, actually. AI is already a part of our life and will stay, I believe, and will grow and will improve over time. Yeah.
Yeah, definitely. So for KPIs, we covered in the beginning that for governance, you should have all these metrics for automation stability, for feedback from production, I mean defect leakage. You need to understand your baseline for test design and other metrics and use cases that you're introducing. So governance is a key. And during the adoption and after adoption, you will return to these metrics. And what we understand, during adoption, of course, you need to first measure time for learning, measure time for reworking your outputs from agents, how it's increasing or decreasing during the pilot phase. And what we started also to measure currently, it's how much artifacts we are generating by artificial intelligence, and also how people involved and how they active daily usage increasing during the adoption phase.
Yeah, Dasha, maybe worth mentioning that actually, if you start measuring something from the very beginning, because it also was our experience, right? And it was, I believe, was our from my perspective, big mistake that we actually, when we started this journey, we wanted to see some real results, right? How many people are using? How often? For which case? Why are they actually the productivity gain? I still do believe that it wasn't the right moment to do this. Just make you need to be patient. You need to be patient with that, right? And introduce
of course.
work and introduce some KPIs, but not from the very beginning.
Even to be prepared, for example, for test design time, it can even be decreased because team need more time. They need time to compare their results. Yeah, so everything can happen on this stage.
But also the LLMs itself, they are also evolving, right? They are also improving, and the models we were working at the very beginning, 1 year back, it was not comparable with what we have now, right? It's also this. It's actually the not only you and your team, but also the AI itself. It's also improving.
Yeah.
Maybe just at the end of our presentation, this is the last slide. We just wanted to share some I don't know, from our experience, some hint with you that, from my perspective, you always need to make or to bring a little bit of fun to what you are doing, because it's technology. Yes, it should be excited. And I know and understand that you need to get the feedback from your team while you are driving this experience. This is actually the way we choose. We choosing this Daria when we just introduced this. There were some first steps. What we did and how we managed to actually at least measure at least something, right? We introduced this in the funny manner. We introduced the Mentimeters. You know this, actually, this platform when everyone sees the results immediately, how others are answering on some specific question. It's very interactive. You can convert or you can bring a little of fun into what you are doing. Just not because, oh my God, everyone needs to adopt AI, you need to meet the KPIs, you need to be on the market trend, you need to be on the demand on the market. Yeah, just like make it a little bit like more funny and more, because it's the life is so complicated. Why to overcomplicate it even more? So this is the way we've used with Daria to measure the progress.
Yeah, totally agree. With the Mentimeter, at least you can like have a conversation, like real conversation with people, even if feedback is negative. Okay, like we need to try to convert it to positive, and it's our ways to improve our process.
Yeah, that's all, guys. So just like we live in an exciting time, really, and we just don't need maybe to be very serious about, and it will help all of us to adopt new technology and to become more productive and also on demand on the market. Yeah, that's pretty much it. Okay, so that's it. I don't know what should happen next. I believe we should have our helper. If we have any questions, I don't see any. Nevertheless.
Hello, everyone. Wow, superb. I'm confident that your presentation has been extremely valuable for our audience. We have received a few questions from the platform. Let's discuss them. Well, what were the most unexpected challenges or failures encountered when scaling AI in enterprise quality engineering, and how did your team address them? Who answered, Natalia or Daria?
Dasha, I do believe that we have the same vision on this question. What was the most challenging? Let's experiment. What do you think? What was the most challenging moment in our journey?
I think people motivation and willingness of work with
so this is, and how did we? Yeah, so it was for me personally. It was kind of like unexpected, because I thought that maybe everyone will be so happy, to have someone, but we really didn't expect, and I don't believe that anyone in the market expected that actually there will be a natural feel of, okay, AI. Even sometimes you even don't realize by yourself that you're like not trying to bring this new technology to your life because of some kind of thoughts about the if my profession will be still needed, right? I don't believe it's actual at the moment, right? Dasha, what do you think? I don't believe that.
Not yet.
Not yet.
Definitely.
So what will happen? Will AI, specifically in QA era, will AI replace specifically professions? So we also had a lot of thoughts and discussion around which profession will be affected the most, which profession, how the profession will be transformed. So, and as I said, that is why I'm like so many times we focused the attention about the change management. I don't believe that we were ready for that, right? I don't believe we had like a proper soft skills specifically in change management area to effectively drive this change and to help team members and to help ourselves to adopt this new technology. And I think we also shared how we specifically, what was our way to address them through the trainings, right?
Yeah. Education and trainings.
Absolutely.
Very interesting. Next question. How do agentic flows, where AI agents autonomously handle subtasks, impact team workflows and project delivery timelines in practice?
Dasha, it's totally yours.
Yeah, I can try to answer on this question. So actually, it's providing more work, firstly, for us, because we need first like to teach team to be part of agentic flow and to gain new skills and new experience how to verify output of these agents, because it's not something simple for us, because we are still we are not working with AI agents mostly as a product. Currently, AI agents is more like our helpers, but still we do not need to forget to validate and how to validate, to inject quality gates, more strict quality gates even than before, because now you have agents work for your test execution, test design, and between that you need to inject this human review to be ready to verify all response and approve and provide your sign that this part is ready for next stage for agentic flow. In practice, of course, it can slow first, in first adoption phase and stabilization phase, it can slow your delivery timeline, because you need to understand how to work with that to stabilize your agentic flows and pipelines. But after that, you can then free some time for your improvements, for analyzing some retrospective session points that you have, and free time for something that you know to improve. I mean, in testing process and application as well.
Oh, really? Cool. And the last question, what best practices or governance frameworks do you recommend for ensuring transparency and accountability when integrating AI-driven processes into enterprise quality engineering?
Well, this is actually quite a complex question. What best practices or governance framework? Dash, do you have any thoughts? I need maybe to
Yeah,
think. I believe that it's
yeah.
not about the framework itself, right? You need to establish what is relevant for you, and we already shared some KPIs and measurement we've collected, but I don't believe this is actually the framework itself, like the governance framework itself has changed dramatically. It was like moving from the governance or from the framework we have at the moment or we had at the moment. It was just like naturally moved into some next stage, like collecting some metrics about the AI adoption, and it was a natural process as for me. I don't believe that we have changed it a lot, right? What do you think?
Yeah, I don't think so. So I think the baseline that we shared in the presentation, that you should have governance on each level and on each stage. Moreover, this governance should be applied and followed by each team. Without that, you cannot align your IA agents, prompts, or pipelines without following this governance approaches, frameworks, or whatever. And how to ensure transparency, it's only when each team is following this governance framework, like following these approaches and best practices, and only after that, we can have transparency between IA adoption, because everyone is using the same test case format, then they can apply the same test design pipeline.
Yeah, and you can have a proper transparency, because if you don't have any unified process, it will be really very hard to build a bigger picture and also to measure the AI adoption against this. I mean that I wouldn't say that there are some like totally new best practices, right, in the quality engineering framework. Nothing new, just like you need to you want to accelerate the delivery rather than to build some absolutely new framework. This is actually how it works from my perspective, right? So we've just added some more KPIs or some metrics. But I don't believe that we have changed dramatically the governance framework with AI introduction. You still need the people still accountable and responsible for the whatever decision or whatever output you are getting from AI. This is actually, there is no change in this approach, right? You can make it faster, you can do more, definitely, you can accelerate the delivery itself, but there's not yet the absolutely different framework. Maybe it's also will be the next stage, Dash. What I think that it will be next stage, right? When we have like multiple agents in place or pipelines, then we will need to rethink about the framework.
Yeah, AI governance and something, that's our future, like to have this AI governance and monitoring framework for like monitoring and checking results of AI agents response and output. So that, we will
That is the
definitely transform.
next phase,
Yeah.
next stage. I think that we, at least for our setup, we are just only heading to this. This is
Mhm.
actually something we will tell about this to the on the
Next
next
time.
conference.
Yeah.
Natalia, Daria, thank you so much for your inspiring and very useful presentation, for your clear, informative answers. It was great to hear your practical advice. You truly energize and motivate us to move forward. Thank you for sharing your experience and supporting our professional community. So, follow us on social media to catch all the cool stuff. Don't miss our special challenge. Stick around and join the fun. We've got awesome talks from our speakers, fun contests, and cool prizes.
Okay. Yeah.
Thank you.
Thank you.
Folks, we're having a fantastic competition for all attendees, featuring great prizes for those who complete the contest terms. The only condition is to tag us and submit on any social platform and then win a prize. More tags, more chances. Good luck. Are you ready to meet our next speaker? Okay. So let me introduce our speaker, who is a specialist with over 6 years of experience in software testing. She has expertise in various types of testing, user support, as well as project coordination and resource management. Her background includes successful work in healthcare, fintech, e-commerce, loyalty programs, and AI solutions. She will share insights on how agentic QA enhances delivery in complex enterprise environments, covering real cases and key challenges. Meet Daria Alexeyeva. Daria, go ahead, over to you.
Hello, everyone. Hello, glad to be here today. Let me share my screen. Okay, you should see it right now. Let's get it started then. And the title of my talk is What Actually Happens When Agentic AI Meets Enterprise Reality. And I want to start by saying what this talk is not. It's not a product demo, it's not a roadmap presentation, and it's not a product success story where everything worked perfectly from day one. This is a field report. In development and demos, agentic AI looks straightforward, but the real test starts when the tool enters enterprise delivery. POCs, real environments, real stakeholders, and real constraints. And that is the journey I want to walk you through today, from it works in the lab to it works in production reality, and hopefully a few lessons that can save you time, friction, and pain. If you're a QA leader, a manager, or an individual contributor thinking about what AI native testing looks like beyond the demo or control environment, this talk is for you. So let's get into it. Before we dive in, a few words about me. My name is Daria Alexeyeva. I'm lead software testing engineer working closely with AI-driven testing initiatives, from test strategy and coordination to bringing AI tools into real delivery workflows. I worked across different enterprise products and domains, and for me, enterprise reality means complexity, multiple teams, legacy systems, strict timelines, unclear ownership, and a very different definitions of what done looks like. Outside of work, I mentor test engineers, speak and write for testing communities, and teach kids the basics of software testing. I believe technology creates value only when people are prepared to use it well. And that's exactly what this talk is about. Let's move on. And this talk follows one path. First, what agentic AI is in principle, then what happens when it moves from development into enterprise delivery, and finally, what we learned from real POCs in the field. Before we go any further, so here's what I want you to leave with today. 4 things: practical, honest, and hopefully useful right away. First, a clear picture of what agentic AI is. There was a separate deep dive session on the product. So here I'll give you only the short version, enough context for us to speak the same language. Second, real delivery stories, and I'll show what it looked like once agentic AI left the demo environment and entered enterprise pilots, where timelines, stakeholders, systems, and expectations all matter. Third, honest lessons. What surprised us and what was harder than expected. And finally, a delivery mindset you can take with you. Just a practical way to think about bringing AI native testing into complex organizations. Whether you are considering agentic AI, another AI testing tool, or any new technology in QA, you will see these lessons still apply. All right, let's start with the tool itself. And what is agentic QA? So agentic QA is an AI native solution. In this context, that means we don't start by writing automated UI tests as code. We start with a natural language check, a short description of what needs to be verified. For example, as you can see on the screen right now, when clicking the Add to Cart button, verifies that the cart icon updates to show the item was added. So the input is not a script, the input is intent. Agentic AI uses purpose-built agents to turn that intent into test execution, navigating the interface, understanding context, and validated outcomes. Not just did the button appear, but did the right thing happen? What matters for this talk is the basic idea. We're moving from writing scripts to describing intent and letting agents handle execution. And crucially, these agents don't just execute, they reason, evaluate, and make judgments about what they're seeing, which matters enormously when you are testing, for instance, AI-powered products, right? This is also where enterprise reality starts to matter. In demo, that shift feels simple, and in delivery, it changed to who can contribute to automation, how fast checks can evolve, and where maintenance effort goes. Because the real question is not what the tool can do in demo. The real question is what happens when you take it into the enterprise world. And here's where it's getting interesting. When you take any new technology, especially AI native technology, into enterprise environment, something happens. The gap appears. Every enterprise pilot we've run has encountered the same version of this. And the first gap is environment complexity. In demo, everything is clean, controlled, and predictable. In the production enterprise environment, you have legacy integrations, unstable infrastructure, custom authentication flows, and environments that behave differently on different days. And complexity doesn't add, it multiplies. The second gap is ideal scope versus actual client readiness. We go into a pilot with a plan, a scope, and timeline, and then we manage the organization. And the organization has its priorities, vacations, procurement processes, test documentation, and a very different understanding of what ready to start means. And this is not unique to agentic AI. This is enterprise delivery. And readiness is not a given, it has to be built. And the third gap, and this one is critical, is AI expectations versus AI reality. Clients arrive having seen demos, read articles, maybe watched a keynote. They already have a picture of what AI can do. And that picture can be accurate, but sometimes it can be too pessimistic. but sometimes it can be too optimistic. And managing that gap between expectation and reality requires active, deliberate communication. Expectation management is not a soft skill, it's a delivery discipline. None of these gaps are reasons not to adopt AI native testing. They are reasons to approach it with discipline. And that discipline is what the rest talk is about. And before we go into cases, let me ground this real field evidence. I want to be clear about these numbers. They came from 7 enterprise pilots across 4 industries, different products, different constraints. We created more than 300 checks, and it's not we automated everything. It's the result of focused POC scopes, iteration, and gradual expansion. We found more than 30 defects, and it's important too, because in enterprise delivery, value is not only speed, it's finding real issues in real environments. In some cases, up to 50% of manual testing effort was freed up and redirected to high value work. The 3 cases I'll show next are part of that broader picture. They are representative delivery stories. Let's take a look at those 3 pilots in more detail. The first one related to education, and the client had an AI-powered application, meaning the product itself generated content with an LLM. And that changes the nature of testing. We walked into was not a simple UI test suite. The product generated content dynamically. And the validation question was not only, did it work, but what's the output correct? And that's a different testing mindset. And it's exactly where the reasoning layer mattered. Agentic QA reasoning layer made this possible because agents doesn't just execute, it evaluates. So we were able to run functional testing and LLM output validation in the same flow. Also, we built a completely new workflow for this client, automated conversation runs with structured response capture and time-stamped outputs for trend analysis, and something that didn't exist in platform before. As a result, 40 checks, 9 weeks, and 9 defects found. The second case is from retail sector, and here the challenge was different. The client had scenarios that were genuinely hard to automate, dynamic UI, brittle scripts, and cases usually left for manual testing. So the question was direct: can agentic QA handle the cases that traditional automation struggles with? And the answer was yes, but only after we scoped the pilot around the right steps, scenarios, and stabilized the execution path. We didn't try to automate everything. We focused on high-value scenarios that were fragile, hard to maintain, or difficult to trust at scale, and proved the approach in real delivery contexts. And as a result, 31 checks across iOS, web browser, mobile viewport, and 3 defects found. And the third case, it's digital services. The POC required depth quickly. The client needed full end-to-end scenario coverage, plus a custom workflow for file upload, processing, and management. So this was not just run checks against an existing flow in agentic. We had to extend the platform around the client's real process. And what this case demonstrated is that agentic QA can be extended for client-specific needs without sacrificing stability. That accessibility matters for enterprise adoption because no 2 enterprise environments are the same. And result, 50 checks, 9-week POC, and a custom implementation delivered within the pilot. Across all 3 cases, industries differed, technical challenges differed, and scopes differed. But the pattern was consistent. Agentic QA created value when it was applied to real delivery problems, not just demo-friendly scenarios. And that's where the lessons become very clear. And let me move from the cases to the lessons. And nothing groundbreaking here, but these are the lessons that kept showing up across pilots, and they're easy to underestimate because they sound too obvious. And this slide is about delivery, scope, and client engagement. First, define scope and pilot boundaries early. When scope stays open, you observe unplanned integrations, timeline shifts, and expectation drift. And that costs time, resource, and trust, always. Second one, plan around real enterprise constraints. Vacation, approvals, release freezes, delivery breaks. If they are not visible upfront, they become surprises. And surprises erode confidence. And the third, manage AI expectation actively. Clients often expect the tool to understand everything from day one. And the team needs both technical depth and clear communication about what's realistic. And finally, here, a POC without roadmap stalls. A successful POC proves value, but without next steps, ownership, and client readiness agreed before it closes, momentum fades fast. The time to align on where this goes next is before the POC ends, not after. So the message I'd like you leave with from this set of lessons is this: POC success is created before the first check is written. And the second set of lessons is about platform, collaboration, and trust. If the first side was about setting the pilot up right, this one is about keeping confidence alive during delivery. And first one here is speed and stability are non-negotiable. You need to stabilize early. In some of our engagements, environment instability was causing execution problems at the start of the pilot. And there weren't issues with the agents itself, but they presented that way to the client. So the lesson is straightforward. Address environment stability proactively, browser stability. It's much harder to recover trust after the fact than prevent the issue upfront. Second, support real-world execution needs. Multi-browser, multi-device, multi-location. These are not edge cases for enterprise clients. They are baseline expectations. Our delivery approach needs to reflect that. Third, share metrics consistently. This one is about visibility. Without clear, regular, accessible reporting on progress and quality, pass rates, trends data, test outcomes, clients can lose confidence even when the work is going well. Sharing metrics proactively and clearly is part of delivery. It's not nice to have. And finally, align teams and bring expertise to complex conversation. Alignment across full delivery chain, client team, your team, account managers, other stakeholders on scope, priorities, ownership, and decision making. And when those conversations get complex, technical expertise needs to be on the client calls, not only in async threads. When a client raises a technical question or a complex issue, that conversation needs someone who can answer it precisely and confidently. Async handling of technical complexity creates confusion and damage trust. And structured reporting and shared trash matter, but alignment and clear technical communication keep trust alive during delivery. So deliver reliably, communicate visibly, and earn trust. So what does good enterprise delivery actually look like? I want to be clear about this slide. This is not a new methodology we invented. It is a way to describe what successful deployments had in common across multiple engagements and to make that structure explicit. Phase one, align. this is where everything starts. You need shared clarity on scope, pilot boundaries, KPIs, reporting cadence, documentation, client readiness. You need to know what you are building toward, who owns what, and what success looks like. In our pilots, this is where we prevented POC drift before execution even started. Phase 2, stabilize. This may not feel exciting, but it matters a lot. Environment and browser stability, onboarding, training, executions, and communication protocols. All of this removes blockers before they become escalations. And if this phase is skipped or rushed, the pilot usually pays for it later. Phase 3, proof. This is where the pilots start creating visible value. You execute runs, share metrics proactively, manage expectation, and keep feedback loops active. And the important word here is visible. It is not enough to deliver value. The client needs to see it clearly and consistently. This is where outcomes like automated checks, defects found, and maintenance savings become more than numbers. They become confident signals. And phase 4, scale. And scaling means moving from proof to production grade delivery. A shared roadmap, cross team ownership, platform maturity, developer support, and process standardization. If you try to scale before alignment, stability, and proof are in place, delivery becomes fragile very quickly. So the framework is simple: align, stabilize, prove, and scale. Each phase depends on the one before it. And the point is not add more process, it is to make successful delivery repeatable. And if there is one idea I want you to take from today, it is this one. The technology is ready. Agentic AI brings AI native precision purpose built agents, no code UI automation, and a reasoning lawyer that can bridge manual and automated testing in ways that were not practical before. But enterprise success is not earned by technology alone. The gap between a great demo and a successful enterprise deployment is a product gap, and it is a delivery gap. And the good news is the gap is closable. We saw the ingredients on the slide: alignment, realistic scope, stable executions, visible progress, honest conversations, strong collaboration across teams. And none of this is magic and none of it is new. But in AI native tooling, where technology moves fast and enterprise environments are complex, getting the basics right becomes the difference between a promising POC and delivery that actually scales. So remember, delivery is yours to own. And that's it. That's the whole talk for today. Thank you. Thank you for your time today and for staying with me through real side of enterprise AI testing. And if any of this resonated with your own pilots, constraints, or delivery challenges, I'd like to hear your perspective and Q&A. Thank you. Okay, and now we need...
Wow, superb, cool, very helpful. And so, Daria, our first question: what were the main challenges of implementing agentic QA in enterprises, especially with integration, and how did you address them?
That's a good question. So for me, I guess the clearest example was one of my projects, and that product wasn't a simple UI flow. It was a full end-to-end journey with several integrations to different tools, and every step mattered. And each step had its own validation point. So testing wasn't just check the feature or check the model. It was prove that the whole chain still works step by step. So in the POC, we made a deliberate choice. We didn't try to automate everything on day one. we started with the first critical layer, and that gave us something concrete to prove quickly. The approach works in a real enterprise context, not just in theory. And once we had the baseline, we didn't stop. We come back to the client with several scaling options for how to extend coverage across the full end-to-end flow, including the integration steps we hadn't automated yet. So our approach was start narrow, prove value, and then expand with a plan, not automate the entire end-to-end flow or chain immediately and hope for the best. That's what makes the difference, I guess, in a complex integration environment.
Super awesome. Thank you, Daria. But we have second ones. Can you share a real example where agentic QA improved delivery speed or quality, and what made it successful?
A very practical example was UI redesign. We had to update a few checks according to a new design of the product and compare it with traditional automation. And with traditional automation, that took about 4 hours. Broken selectors, script rewrites, maintenance work. And with agentic QA, we updated the same checks in about 14 minutes because we changed the intent in the natural language, not the scripts. And that was a real win, much lower maintenance costs when the product keeps evolving.
Very interesting. And last question, Daria. What best practices help overcome resistance and ensure smooth adoption of agentic QA in enterprise teams?
In our experience, resistance usually comes from two fears. This won't work in our environment, and this will create more maintenance. And what helped most was starting small and proving value in controlled way. We didn't push full end-to-end automation on day one. We align on focused POC scope, stabilize the environment, and only then demonstrated real outcomes in production-like conditions. We also made progress visibly. So, as we discussed today, concrete results, real defects found, and clear next steps, not just AI can do amazing things. And once teams saw real value, adoption got easier. The barrier was lower, and people felt they could actually use it and integrate it into their workflows, their processes. So the pattern is simple as we covered. Align first, stabilize early, and prove value visibly, and then scale with the plan.
Thank you for your participation in the summit, your thoughtful answers, and the valuable experience you shared. We also appreciate your engaging presentation and the practical insights you brought to the discussion. Your contribution was truly inspiring. So folks, our incredible, amazing AI Summit has come to an end. Special thanks to our speakers and huge thanks to our participants. Follow us on social media so you don't miss any of our events. We will let you know about the social media competition results there. You are the best. See you in the future, which is already here.